Okay, so everyone can see this computational BIM community of practice, right? So for today, I'll be sharing two components. The first one is actually the past events. Another one is a quick report on the survey. Okay, so for past events, so it's actually started from 2019 to date. So as you can see, we actually have a monthly small group meetup, bi-monthly sharing, and also 2-day intensive workshops. So all the workshop details is publicly available. So at computation.space. So this is actually past activities at one glance. So the slide actually shows all the past bi-monthly sharing session with consultants, contractors, and our solution providers supporting all of these efforts. And of course, with the COVID-19, right, I thought the growth is actually affected, but actually with the webinar in place, there are more people enjoying the know-how sharing openly and generously, supported by the industry partners, especially Autodesk, that they actually supported every sessions over the past events. And as you can see, our Daniels from ONG&ONG was in the picture since Renee from Woha was hosting the first small group session. He was also leading a small group discussion and later panel discussion as well. So 1 year later, we are very thankful to ONG&ONG and Daniels for hosting and leading this session to celebrate its 1 year anniversary. Okay, so actually we started a survey since May last year in a master for the attendees for the master class. It started off from 50 packs only, and it now grew into 500 different contacts that participated for our last events. So it actually comprises 200 and above organizations. So these are some of the flashbacks. So we thank Singapore Poly for hosting the physical workshops and sharing sessions in the forum, and of course the DBIG, Mr. Chris Ho, and Mr. Dennis Goh, Junita, Tian Seong, Chun Kiet, and the supporting team behind. So for all the past events. And of course, as you can see, we have Wahab leading first contractor session with Man Kwek sharing his experience. Then we have John Rivas from Autodesk leading the first session, introducing the concepts of computational approach. As you can see, so it's a very comprehensive. Then the DBIG, Chris Ho leading the consultancy and the BIM courses. And of course, Junita and Tian Seong leading the competition, which is actually concurrently ongoing. Today is the assessment day. So, and then this is the second sharing session. So the first session is actually led by our contractor. Then the alternate one will be consultant. Then moving on forward, then back to contractor. So this is our arrangement. Then as you can see, John actually shared Project Frog with DfMA. And we have Vignesh shared about design intelligence with the human factors behind. So lots of designs being generated within a very short period of time. So as you can see over here, so there's a public feedback session to look into the top challenges for good documentation. So then of course, okay, so these are the workshops that collated all the real task-based problem. So from zero to hero, after attending this 2-day workshop, right? So the attempt is to convert some of the tasks into scripts. So as you can see, these are some of the listed topics. And then moving forward, we have Edmund Raymond from Stritch Construction to share the computational BIM implication, the safety aspects. Then and we have the solution provider, Magicsoft, Kenny, actually did a live demonstration, integrate BIM into live video on-site for progress monitoring. And John also shared about BIM 360 on safety management. Then we have IDA. So during the COVID-19 pandemic, actually IDA hosted a session to introduce their VR studio. As you can see here, this is their studio, very small but comprehensive. With computational VR, what it meant is you can actually tweak all the parameters in your laptop while visually viewing engage in a 3D immersive environment. So Aloysius presented his involvement in Future of Earth by SUTD and some of his works as well. So John shared about using Dynamo for more applications, especially in safety. So in the past events, we have three topics, which is documentation, safety, and code compliance. So for this, actually John and Ken actually led our first full-day technical webinar with Dynamo Revit. It's free to public. So as you can see, we move on to the webinar sessions, and Autodesk actually generously supported on the cloud solution with generative design. And Ping Lei from CPG shared about Python Rhino calculating the unprotected opening, a very detailed session. And all of this past session is actually available in the website now, recorded. So supposedly ChinaCon should be shared, but he can't make it due to the COVID pandemic. So Jeremy Heng from the Cloud Mile shared about cloud services for the B sector. And moving on, we have the recent workshop, so supported by Autodesk again. So John and Ken actually supported. So this is the workshop, the Computation.space. As BIM origin was closed, so Computation.space is introduced to continue the efforts of the computational BIM sharing as the resources. So let's move on to the recent survey report. So I have a few slides comprehensively shared the opinion of the respondents. We sent to 450 participants. So from there, right, we received 119 responses. First thing, is it useful for computational BIM? And 90% get a certain is useful. Have they started using it? So 40% mentioned they've started. Then why, if they are not using it, why are they not using it? So most shared that, mentioned that they're still in a learning process. Some mentioned they do not know how to do it. Some mentioned that that mainly due to their contract and job roles. So after investigating with phone calls. So, and if you're using it, what are you using it for? So it's quite evenly distributed from concept design, design development, tender documentation, construction documentation, and others as well. So what are the hurdles, which means the difficulties when you are encountered in applying computational BIM? As you can observe, is a steep learning curve. Okay, and then of course the insufficient resources and slow at speed. What does it mean? Slow at speed is sometimes the visual programming, when it comes to certain complexity, the software will hang. So therefore, the problem is how to move forward with this. So I suppose there could be solutions that you guys can share with us. So therefore, we're asking, can you share your computational BIM experience in one of the upcoming webinars, such as a talk? So 20%, roughly 70% mentioned yes. And then can you share it in the website? 20% mentioned yes. Then of course, moving forward, so we're trying to collate the responses, as you can observe. So 75 respondent or 63% mentioned that programming is preferred, right, together with visual programming. So next one is they would want to learn specific software, such as Rhino.Inside.Revit, Houdini, and others that they mentioned in here. So game engine and VR also is one of the options they opted for. Then I hope the above give a very general big picture of our activities and the survey. So please do visit this website so that you can understand and look out for the latest workshop and sharing.
Great, thank you. So hi everyone, I am Harsh Kedia. I work at NBBJ in Seattle, Washington in the United States. So as you can imagine, it's quite late for me. And NBBJ, for those of you who don't know, is a global design firm. We've got offices in the States, in the UK, in India, and also in Shanghai. And I work in the Seattle office, soon to be moving to the Pune office in India, as a design computation leader. Which basically means that my work revolves around computational BIM, design computation, kind of using technology to improve the design process, half the time in my job, and the other half working as a regular architect and designer on project teams, doing detailing, design optimization, and so forth. So today I wanted to talk a little bit about how we as NBBJ approach this issue of computation, and a little bit of the history of how we as an organization have done it in the past and how that's been reflected in our day-to-day projects. So, design computation is kind of the sister idea to computational BIM. And I just wanted to kind of relay the history of how we've been doing it so far. So let me go to the next slide. First of all, I just want to thank the main core team that I work with on all of these topics. Nate Holland, who is our kind of team leader, he's the design innovation director, Peter Mitev, who leads the global design computation team, and Nathan and Joseph, who are both software developers that I work with on a day-to-day basis to build out firm-wide tools and optimizations for all the designers in the firm to use. So just to give you guys an overview of what I'm going to be talking about, first I'm just going to kind of discuss what design computation is, what is it that we do, give a bit of a history of how our past tools were developed and how they sort of showed up or how the results showed up in projects. And then I'm going to talk a little bit about how we're doing our tool development now and the process of that and how that's also showing up in projects. So just a kind of history, just a kind of past and present of how we've been making computational tools at NBBJ. So first of all, this question, what is design computation? I get asked this a lot. And to be honest, I don't have a super clear answer. So you're going to have to bear with me on that. But it's essentially a means that we as an architecture firm differentiate ourselves in the market. It enables us to bring more value to our clients. We make our workflows more efficient and effective. And it also is a little bit difficult to understand for most people because it's somewhat vague. And it definitely sort of requires a change in mindset of how we approach the design process. Maybe a better way to understand it is what it is in terms of individual adjectives. So it's an approach, it's a way of doing design, it's a mindset, it's a way of thinking, it's a process, it's in your workflows and how you work, and it's a philosophy. It's this idea that design should be driven by technology, it should be informed by data and kind of driven forward that way. But most importantly, it's not just a piece of software. It's all of these things above, but it's not just a piece of software that you ship and somebody can kind of hit a design computation button and have a great building. That's not how we think of it. So I just wanted to start with a bit of the history of how we've been building these design computation tools at NBBJ. We, for the last about 6 or 7 years now, have been building firm-wide reusable tools in the .NET environment for our designers to be using on a day-to-day basis. And so I just wanted to give you guys a bit of a context on what kind of tools we're building, what infrastructure are we using, and how that's been going so far. So initially, when we started this whole thing of trying to use computers and make design better, we were all a bunch of hackers. We were people who learned Grasshopper in school or kind of played around with it, self-taught coders, and so on. And so when we joined the firm, we were kind of doing this stuff by ourselves. There was no kind of larger organization where we were trying to come together and build tools for everyone else. And so the model that we had then was the tools were built by individual people, the individual coders used the tools, and the ideas always came from projects. There was no kind of ideation or firm-wide kind of force that was giving larger universal ideas that could span across projects just yet. But then we got a little bit better. We got a little bit more organized. And we realized that if teams of people build tools together, the tools are a lot more effective, a lot more robust. We don't just want individual hackers to be able to use the tools. We want everyone and every single designer to be able to use the tools that we're building. And so we changed our way of making those tools as well by improving the UIs, improving the experience, and so forth. And lastly, we realized that ideas don't just have to come from projects. Ideas can come from individual designers, from firm leadership, from everybody, whoever has an idea that could be interesting for everybody else. And so we kind of started to increase the idea pool, so to speak, at NBBJ. And lastly, the big question of cost. So all architecture firms want to minimize overhead and maximize our billability, which is why previously we would always charge our hours to the project, right? If you have a building project and we optimize a facade, we charge the optimization to the project. But more recently, we've realized that by increasing the overhead just a little to make firm-wide tools, we can actually reduce our cost on projects quite significantly. And we'll also increase our competitiveness in the market. And so we've started with this new in-house venture capital kind of program, which is called the JUMP program, where individual designers and individual coders and teams of coders pitch to firm leadership for hours to build on their ideas. And we'll talk a little bit about that in the end. Okay. So I just wanted to talk about what infrastructure we use to build the tools that we do. And primarily in the last 4 or 5 years, we've been heavily invested in the .NET environment, as most architecture firms are. We use Grasshopper, Dynamo, Revit, Rhino, the .NET framework, and C#. That's primarily how we build things. We kind of make Grasshopper scripts or Dynamo scripts or Revit add-ins, Rhino plugins, and kind of ship them individually to designers' computers that they can use as plugins to these softwares. And how do these tools look? So there's a few examples that I have that kind of describe what we've built in the last few years. So this is a tool built on top of Grasshopper and Human UI, which is a framework that we developed in-house to create UIs on Grasshopper. I'm sure some of you guys have heard of it. And this is just a simple example of what the experience was like. This is within the Rhino environment, and we're kind of doing this massing analysis dashboard or control panel that shows, based on any kind of building scheme, what kind of cost comparisons you get and material estimates and so forth. I'm going to go to the next slide since this is more of the same. And the other thing is, this is another similar dashboard that we built, I think about 3 or 4 years ago, and this was more about human experience, more about understanding the interior views and daylight and so forth. Again, very similar to the previous dashboard, just looking at a different idea and getting different data out of it. So this is the kind of ideas that we had in the beginning. We wanted to kind of build these tools that gave you data side by side in your design process, primarily in the Rhino environment. And this worked great for a while. And I wanted to show you guys some of the projects that came out of this kind of thinking and these kind of tools that we've marketed widely. Another tool that, again, you can see is kind of auto-generating documentation for this thing called prospect refuge theory, which is a theory of brain science that we like to use to implement our designs. So in that whole thing you saw, it looked pretty great in some contexts, but we had some issues with this process. First of all, the UI was a little bit dated. I think for those of you who are familiar with Human UI is built on WPF, which is the Windows framework for presentations. And WPF is useful, but it's also kind of old and it's a little bit dated. And it also leads to poor performance, complex workflows, and most importantly, if you want to make any change, you're going to have to ship these Grasshopper files or these EXEs or whatever to 900 to 1,000 designers in the firm each time and have them reinstall it, which turned out to be a huge problem for us. But anyway, going beyond the issues, I just want to show some project case studies to kind of show the kind of things we got out of this way of thinking. So the first project is our Samsung headquarters in America, in Silicon Valley. This project was one where the client extremely heavily asked us to rely on data as a way to inform the design process. And this building was sort of extremely heavily simulated, analyzed, and almost every single formal decision being made is being backed up by tons and tons of analysis and data. One of the most kind of the ones that we like the most and the ones that we kind of show the most is this idea of visibility. The client wanted maximum people to interact with each other. Obviously, in a pandemic, we're not entirely the same anymore. We might not want this exact kind of interaction, but at that time, this was something that was highly sought after. And the client kind of wanted us to see how many people actually see each other face to face as they move around the building. And also how often do they walk, how often do they get up, and how many calories do they burn overall. And this was a kind of simulation that we built on top of Rhino to show this exact data on this building. The other one, which is more towards computational BIM, is the Denny substation in Seattle, Washington. So this is an electrical substation. This is where power comes from the power plant. It gets transformed into a lower voltage and goes to your house. And in this substation, we kind of wanted to design something that was a bit more friendly to the urban context. Most substations are very ugly. You don't want to actually be near them. But we wanted to take the substation and turn it into somewhat of an urban park. And so that's kind of how this form was generated. But to generate this form in the end, we did a lot of analysis and a lot of simulation to understand two main things. One is the kind of performance capabilities of this substation in terms of daylight and so forth. But secondly, we wanted to make sure that people in these surrounding buildings don't have to, or we can minimize their view inside the substation yard. And so we minimize their view of all the electrical equipment, and so they don't have to see things that they don't necessarily want to see. So this is a quick video. I'm not going to go through the entire thing, but it's kind of showing our process of how we went from design to documentation in the days before Rhino.Inside. This was just Grasshopper and Dynamo, and how we managed to get all these panels to kind of work for us based on our sketches and daylight studies and so forth. And as you can see, our Grasshopper script kind of grew over time, representing the different aspects of our design process. But if I just go scroll forward, you can see as we kind of had a lot of rationalization, a lot of design kind of iteration along the way to make sure those panels perform the way we wanted them to perform. And the whole idea here was we wanted to really quickly go from a gesture in Photoshop to a fully rationalized design idea in Rhino or Revit. And the whole idea was, designer can come in, take a spray paint brush and spray a certain pattern on top of this facade, and that pattern gets represented 1:1 based on paneling in Rhino or Grasshopper. And that's kind of the whole idea behind this gestural looking facade in the station. On top of that, beyond the sort of design gesture, we also wanted to optimize the layout of these panels, and we used a lot of daylight and heat studies to understand which panels are getting heated the most and how we can optimize that. And so as you can see, we're kind of doing a bunch of solar studies, and we want to minimize the solar radiation coming onto the yard of the substation. And that also sort of helped us inform the layout of these panels. Sorry. And the last project I'll talk about, which is kind of the project that spawned this whole movement for us in terms of design computation, were the Amazon spheres in Seattle. This was primarily a process of design rationalization, taking an idea that is somewhat radical, at least for Seattle, and trying to realize it in a cost-effective and reasonable way. And so these forms, as you can imagine, were quite heavily rationalized using design computation and Grasshopper and so forth to actually realize how these work. And I was not involved personally on this project, but I can show you a couple of slides that kind of describe the logic of how we came to rationalize the sphere geometry. So the overall structure, the kind of skeleton that holds up the curtain wall, was this little 5-sided shape that we kind of discovered in our process of iteration using Grasshopper. And we realized that this shape is kind of ideal for making the spherical geometry look very organic and not very repetitive, but also kind of help us realize this kind of 3-sphere shape pretty easily. And so this was something that we kind of studied a lot using Grasshopper and kind of came to this final conclusion in terms of shape in coordination with our structural engineers and so forth. And this is kind of a quick video again of how we essentially try to see, okay, we have this shape. How do we get an entrance into this building? That's a fairly easy problem on the face of it, but there's tons of considerations that come into when we actually need to create an entrance based on this structural shape. And so we had a bunch of analysis going on for all kinds of things based on this digital model.
Hi,
okay.
I'm sorry. Yep. I have to interrupt. Yeah, you have 5 minutes because it's already 3 o'clock. Yeah, I need to hand over to the next. But yeah, I'll give you another 5 minutes. Okay, thank you.
Okay, of course, no worries. All right, I'll breeze through this pretty quickly then, since I have only about 5 minutes left. I just wanted to talk really quickly about this .NET thing, and we did a great job at making great projects, and we had great tools to work with, but we had a few issues, and we wanted to sort of evolve our process into the next level. And that's when we came in and we understood what it means to write good software. And software engineering is a discipline that has tons and tons of research and ideas out there. And we wanted to kind of leverage some of those to improve our own internal software development. So I won't go over any of these in detail, but as I'll just sort of say at a high level that we have a lot of software kind of design ideas that we kind of stole from software engineering and implemented in our own workflows to help improve the reliability, the quality, and the reusability of our own internal firm-wide tools. And with this, at the same time, we also moved. This is all of the kind of analysis of how our .NET software worked. But I'm going to skip over this just because I want to kind of show you guys what we do now and how our kind of tooling has changed since the .NET, Rhino native or Revit native tools. Now we as a firm are focused a lot more on web development and web tools that enable us to kind of push new updates on the fly and kind of help us deploy things to designers much easier. The web stack is a lot more different than the C# stack. It's a lot more modern. There's a lot more resources out there. And we also have this kind of continuous delivery and optimization process because of web tools that we use. I'll just really quickly run over one of our web tools that we can see. I'm just going to avoid all of this so I can show you projects, which is the web project case studies. So here, I just wanted to quickly show you some of our web tools and what we've done with this. This is a view analysis tool where we can basically analyze the view you get from any single point in any building. And this is all done completely on the web. So you export geometry from Rhino or Revit into a web tool, and the web tool kind of gives you a view analysis for your building. You can have it point to trees, to people, to all kinds of different factors, and it'll give you an overall spatial quality of your building, which you can export for lead analysis or to show your client or whatever else you want. And so this was a confidential project in Seattle, which we are currently working on, that we ran this web tool on. And as you can see, the UI is quite updated. We can change the business logic on the fly, and we've had great feedback from designers and design teams on using this tool. We also have a web daylighting tool now that you can see here. I'm going to skip through this since the next tool is also quite useful, and I want to leave some space for questions if there are any. And this was another last tool. This is a survey that we send to our clients to understand how the space is performing for them, how they're feeling about the space, and so on. And then we kind of collate that data and kind of represent it to our design team so we can better understand how to serve our clients better. This tool is also a web tool. It's a web survey. It's a link that we just send to our clients, and it was completely built from scratch by our team in order to maximize our customization for what the survey is going to be. So lastly, I just want to say that this new web process that we've been working on primarily relies on these three principles: on modularity, reusability, and reliability. And I would say by moving from .NET to web, we've become a lot more effective at being able to do so. The exact reasons will be in my slides, and if Yvonne allows me, I'll be happy to share my slides with you guys. But if you can take my word for it for now, that moving to the web has enabled us to do this a lot better than we had before. And at the end of it, it leads to better business performance, right? Having a better tool set leads to lower cost of change, higher performance, and most importantly, better experiences for everyone all around, developers and users. And that's kind of the main idea that we are going with in this web tool experiment that we've just started about a year ago. But that was kind of all I really had to show, and I apologize again for not diving too deep into the reasons, but I'll be happy to kind of discuss that offline with anyone if they're interested, or share slides or anything of that sort. But yeah, I'm gonna stop it here and feel for any questions if there are any, or pass it on to the next person. Stop sharing my screen.
So let's take a look if there's any question related to. I'm just going to go open the Q&A for short for you. So let's take a look from the live event Q&A panel. Just give me a moment. Yeah. Okay, some question actually asking, is the visualization mainly done using JavaScript? What's the JavaScript library used for the UI?
Yeah, so we are heavily invested in Vue as our main JavaScript framework, and we use Three.js as our primary rendering engine for the web. So that the JavaScript tool you saw was built on Vue and Three.js on the front end, obviously.
There's another question, just a quick one from Priya Chachondia. Okay, I hope I pronounced correctly. Okay, she's asking, can this analysis tool be used at all phases of the project or mostly the design phase?
Yeah, so one of the main reasons we shifted to web tool was this idea that we could export from both Rhino and Revit directly to the web. And so the idea is here, you can take a Revit model that's in CDs hit a button and it exports it to the web and you can run analysis right away. And so the answer is yes. We have designed these so you can have it run at all phases of the design project.
Okay, thank you. Check again. Okay, there is an anonymous question. All right.
Sorry, Yvonne, I just saw this question from Han that I quite like. Do you mind if I just read it out really quickly?
Oh yeah. Okay, sorry, I missed that. Okay, so how does NBBJ encourage push these changes throughout the organization? Okay, and okay, the second question: how long or how much budget does your internal VC allow for such development project?
Yeah, that's a great question. So I think learning new tools and developing to change is always difficult and especially for architecture firms that have been doing things in similar ways for so long. And I honestly think it's up to us as people who build these tools to kind of enable our designers and design teams to do it. And I think there's two ways we do that primarily. One is by showing the value, right? The fact that our clients want this stuff and demand stuff like view analysis and data really helps push our designers to adopt these new technologies. The other thing is we want to make as easy, seamless, and great as user experience for designers as possible. If we don't focus on the end user experience, people are going to be a lot less likely to use our tools. And so we as a team have UX designers and actual people who do this for a living help us think through some of the UX problems of our tools. And that's been a great way of kind of pushing this change through our organization. The second thing is, the second question Hannah asked is how long or how much budget does our internal VC allow? To be honest, it depends. Obviously right now things are hard for everyone and our budget is lower than it normally is. But typically in a year, we do build between 4 and 5 firm-wide tools of different scales and sizes. And that it usually means a team of 3 to 4 people working full-time building these tools, which in my opinion is quite a great boon to have as a firm.
Oh, there's another question is that from YQ, what's the best format to go from Rhino.Revit to web?
Yeah, that's a great question.
JSON, yeah.
So we are currently using OBJ, which is a good format and it's very easy to understand and easy to use. But there is another format which is even better in my opinion. And now I'm completely blanking on the name. I think it's called it's a GL format. I'll send you guys the exact name. It's not GeoJSON. It's a JSON-like format that's for the web for 3D models specifically. But that's kind of the future of moving 3D geometry to the web. And I think OBJ and this new web format that again I'm blanking on the name of. I apologize. Are the best ways to go from Rhino and Revit to the web.
That's great. Okay. Let me go through again if there's any question. Okay, from Mark. All right, so this will be my question to you because I have to hand over to the next speaker. Yeah, he's asking how many software developer is in your team now, in average.
Mm-hmm. That's a great
yeah, this is from Mark. Yeah.
Thanks, Mark. So I think we as a team of design computation people like myself who are half architects, half developers, there's about 15 of us firm-wide. So, you can say there's 7.5 full-time software developers in this team. And to top that, we have about 4 people who are full-time developers, and that's all they do in the firm as well. So it's a kind of mix, but I would say about 10 people working on development at any point in time in the firm.
Okay, so okay, I'm gonna hand over to the next presenter. Okay, thank you very much for sharing. Yeah, so we can see your presentation and the webcam. Yeah. Okay, you can start now, Professor.
Okay, thank you very much. Can you hear me very well?
Yes, we can hear you.
Thank you very much for the invitation. And as you can see from my title, I'm here to share my experience on how we prepare the manpower for the industry. So one thing I want to, my name is Moshood. I'm Assistant Professor of Building Services Engineering at SIT. I'm also the Deputy Program Director for the program. So our primary purpose at SIT, specifically Sustainable Infrastructure Engineering Building Services, is to ensure, our primary aim is to ensure that we train manpower that are job ready that is upon graduation, they get on their first day of job, they are ready to work. And hopefully the experts in the industry will also find it easier for them to train them in the line of their business. So, and our objective to fulfill this aim, our objectives are how to make our students mechanical engineers, because we are training them to be mechanical engineers, but we primarily focus on the building industry. So, how can we make them building engineers that are that are well grounded in sustainability, that are well grounded in building issues, and also how to make sure that they are well grounded in the issue of DfMA, process management, in order to improve productivity, and also how to ensure that they are well grounded with regards to integrated digital delivery. So my main discussion today will focus more on the aspect of the integrated digital delivery aspect, or narrowing down to the computational aspect. So you can see from what I'm showing on my slide now, these are the courses that we offer them from bachelor to the master level. Because of time, I won't go into the details, but I'll be more than happy to share more on what we are doing at SIT to make our student job ready. But what I want to point out here, which I'll be talking about later on, is also this year 3 program. In this year 3 program, we try to put the student outside. They will spend 12 months in the industry. And in these 12 months, they learn from industry experts, the current practice, and especially with regards to computational BIM issues. In fact, majority of our students, they realize the need for computational BIM during the IWSP. And we also, the professor, we listen to the industry professionals, and they give us input on their need on the industry. So that is why we try to improve our curriculum by integrating these computational aspects into our program. But to train students to be computational BIM experts, what does it take? It's not just about using a computer or just doing simulation and everything like that. Majority of people can do that if they learn how to use it. But the most important thing, the main reason why we want to use computational BIM is because we want to solve problems. And we want to solve problems in a way that it will be faster. We will remove waste in our process. So for them to be able to do this, specifically with regards to computational BIM, they need to be well grounded in the issue of using Revit, for example, or other software in the built environment. But we focus on Revit for training our students on how to develop BIM models. So in year 1, they start with engineering drawing. Obviously, there will be a lot of mechanical engineering stuff and mathematics. I won't go into the details of that. And they learn a lot about this Revit. And majority of them, they came into the program with very little knowledge about how to use this Revit, specifically for the mechanical aspect of it. Majority of them learned 1 or 2 things about architecture during their polytechnic, because majority of our students always come from polytechnic. About 95% are always from polytechnic. So majority of them are not familiar with mechanical engineering aspect. So we train them. In year 2, they learn about sustainability. Then we also have design studio, and later on they also learn about how to use BIM for energy simulation, for facility management, and in their design project also, the majority of them use it a lot. So what I'm trying to show you is that I will take you through their journey. In year 1, this is an example of work done by students when they first came into the program. So we gave them design brief for them to design something like that. So we trained them how to use the software from scratch. So that took a lot of effort to do that. And they did projects in terms of group projects. Then later on, they moved to year 2. In year 2, we gave them individual work. About 70% of the work was individual. So they did this kind of work on individual basis, high-rise building, in a design studio setting. In fact, for the student, before training them, I always tell them in my design studio, this design studio is not about using Revit. Design studio is about designing. Because like the previous presenter said earlier on, design is different from using computational stuff. You have to know how to design first, you know how to solve problems. So design thinking was the primary focus of this design studio. So, and they learn a lot of design philosophy in this studio. So they designed something like this. So this was done by a year 2 student on individual basis. They designed something like this. So basically they designed from scratch. I gave them brief, and they were supposed to design the architecture of it, and from the architecture Revit, then they convert to mechanical. So for students to come to be able to develop something like this, they have to go to different resources online, different Revit community, to learn a lot about how to solve the problem they encounter with regards to the computational part of it. But design aspect, we teach them a lot about design aspect of it. And if you can see this one, this is an example of work done by the student also. This was done by a year 2 student. And I can proudly say that you rarely find a year 2 student, even in Singapore, a mechanical engineering student. I'm not talking about architecture student, I'm talking about mechanical engineering student, to be able to do something like this. So this is an example of what I meant by we are training our students to be ready for the job, for the industry. Because if they want to do computational BIM, they need to know how to use the Revit, for example. They need to be grounded in it. And they need to know how to design, they need to know how to use their design to solve problems. So they design the architecture part of it, and they design the MEP part. In fact, this is an high-rise building. Everything you're seeing here was done by just one student, and a lot of them did the same thing like that also. And again, this is another example from another student. So when these students, when they came, they knew nothing about the software, especially with regards to the mechanical part of it. And later on, they were able to do something like this. All this was done when they were in year 2, because we are trying to prepare them for the 12-month IWSP program, that is the industry attachment. Then, during their industry attachment, this is an example of work done by one of my students with his team. So they did something like this. Even the student is still an undergraduate student, but he was able to work with the team in his company to do something like this. And during the IWSP also, that is the 12-month attachment, we usually bring them back to the university for about 9 days, and throughout the 1 year, we train them on those topics or those areas that we've not taught them during the first 2 years of the program. An example of such training is the use of Dynamo to actually solve problems in the built environment industry. The person you are seeing here, his name is Lo Juhan. Lo Juhan was one of our students also, and in fact, he was part of the first set. When we started this program, we trained them about BIM and everything like that, but we didn't really focus on the Dynamo side, Python side of it. We didn't focus on that. It was during the 12-month IWSP program that some of our students gave us feedback that they would like to know more about this thing. And in fact, some of them actually used the knowledge of Dynamo and Python for their final year project. So because of the feedback we got from our students, which was part of our plan, and also from the industry experts, then we decided to develop this kind of training for subsequent students in order to ensure that we further increase their skill and capability. We are doing this because of the requirement from the industry, and we work closely with BCA to be able to improve our curriculum also. So we provide training for them, and they use this training for their design project. So talking about design project, usually in the 12-month IWSP, students will identify problems the company is facing. That is, their company where they are working, the problem they are facing. And from this problem, the students are required to now develop a solution to address the root cause of the problem. So what I meant is that, first of all, students must be able to define the problem first, identify the root cause of the problem, and now be able to use their solution to address the cause of the problem. In this case, some of the students prefer to use computational skills to address the root cause of their problem. Some of them are using Dynamo, some of them are using Python, some of them are using different kind of software they think will support them to be able to address the root cause of the problem they want to address. An example here was a student of mine, in which she worked in the FM department in a company, and from during this 1 year experience, she realized that sometimes when contractors or third party is given an assignment to prepare BIM models. And by the time they submit the BIM models to the FM personnel, sometimes the drawings are not complete, a lot of problems with drawings. And I believe majority of you will be familiar with what I'm talking about here. And when you have a BIM model or BIM models that are not complete, the FM people would not use it. They will just keep it. So the whole effort of preparing the model from design to construction stage is now wasted. But our students are well trained to be able to identify problems in the industry. These students identify this particularly for FM industry. I need to make a point here. We are not training our students to be facility managers. We are training them to be mechanical engineers. That means they can work at design stage, they can work during the construction stage, and they can work at FM stage. So in this case, the student decided to use Dynamo for our work. I will show you a video of close together, and when you have this kind of problem with boundaries for rooms, for example, you won't be able to calculate areas. So how to solve this problem? The student use the Dynamo to develop the when you run your and use the Dynamo, for example, to identify those rooms. So to go straight into the BIM model to identify those rooms that are having problems in terms of boundary not joining together. So, and later on, the Dynamo will now be able to differentiate those parts of the model with problem and those without problem. Then from there, Dynamo itself will now collect all the necessary information particular to different spaces inside the model. Can easily notify the contractor or the third party that their drawing is not complete. In fact, those people that are preparing the model also, if they have this kind of knowledge on how to use their Dynamo to identify problems in the design, they can easily rectify their problems before they actually submit to their client, in this case, FM managers. So another example is for some of this information might not be complete. So we are using, in this case, we used an example of our MEP system. My student basically developed all these things. So she developed the program in such a way that the program will be able to identify all the mechanical equipment in the model. So once you identify all the mechanical equipment in the model, from there, you'll be able to what this is another example on how to use Dynamo to streamline process, because it's all about process enhancement. It's all about creating value, because when we talk about productivity, productivity is not just about using computers or using any kind of technology. We make this very clear to our students. Is first of all, you must know how to remove waste from your process before you can add any value into that process. Otherwise, you just be increasing your investment, and all the waste that you have in your process will not allow your productivity to improve, because you've not removed all the waste in the process. So again, teaching students how to use computational skills and knowledge that they have to be able to give value to increase productivity. And this is the point I want everybody to take away. So it's not just about using computational BIM. And again, first of all, you must know how to use your design to identify problems, to identify the root cause of the problem, and use that design solution to eradicate the cause of the problem. So sometimes when drawings are submitted, some of these drawings will just have a duplicated mechanical system. Let's say, for example, the duct could be duplicated because of maybe poor design or forgot to delete something. So, how to identify it? Again, she used this to. So, but the point I'm trying to make here is this. So she basically used I think that the FM thing can use the model because the model is the same as the as built building, so you can easily use it. And I've had a lot of people saying that FM people don't really need what you call computational skills. I believe by showing this kind of example, you better appreciate the use of Dynamo, Python, and different kinds of computational tools. It's not only to enhance the design stage, it's not only to enhance the construction stage. In fact, it's going to be very useful at the FM stage also. So again, she developed. So I can share this slide with you also later on, and again how to update information in view models. Again, how to delete unwanted. And again, how to purge your model. Sometimes when BIM models are submitted, second stage quite different from the one used at the construction stage. So you should be able to delete unnecessary items in the drawing and compact your BIM model. So basically, you focus on developing something like this. So, and we are working on a new project now funded by SIT. And the whole idea of this project is now to take this solution that we've done here. We now want to escalate it to a bigger project in which you have a lot of systems in the drawing, in the building, to be able to now measure the effectiveness of our solution. In the preliminary studies, we actually found that by using this solution, we were able to, one, save a lot of time, obviously, and two, but for me, it's not only about time, it's about accuracy. So we were able to improve accuracy and the efficiency of the manpower of people involved in the work itself. I actually wrote with my students an article on this, which I put in a public space. Again, I can share this article if you, with the organizer also. Hopefully, they can share with everybody for you to better appreciate the details of work done in this area. But be mindful that whatever I'm showing you is a preliminary study. We are actually doing an advantage of it now. Very kind of detailed Dynamo kind of program. Another student from ICT, Infocom department, also helping me to do a lot of programming using Python, and with a colleague of mine from ICT, the professor from ICT. So developing a lot of programs to be able to further enhance the process of identifying problems in models. Another thing with FM, you are very familiar with FM, is asset information requirement. And you know, generally with asset information requirement, you actually have most of your information in PDF. and people will need to type all this information into the Excel sheet one by one. And this takes a lot of time. This takes a lot of manpower, and there's high tendency for a lot of errors to occur. So this is another kind of problem my students identified during our IWSP 12 months. This is another student she identified during her IWSP program. So again, we are pushing students outside there to work with experts, to learn from experts, and be able to identify how they can improve their work process. And this skill is very, very important. So it's not just about knowing what you want to do, but you must be able to identify problems. You must be able to see problem when there is problem. Because from lean thinking point of view, this is how you can basically improve your organization, and it's also part of the philosophy of continuous improvement. So what the student did basically is to streamline the process by developing a solution. Manual process. This case here, I have actually 3 hours. Self study both complete route all the ones of the work. So we go to the next slide. So this is basically the interface of it. So upload the PDF. Basically, it takes save a lot of
Sorry,
time,
Professor. Hello.
accuracy, and obviously one person can actually do the work. And this is very, very important in
Hello. Yeah.
in terms of improving productivity.
Hello.
What I showed you just now was actually text aspect, in which you take text from PDF. What about pictures? For those of you that are very familiar with FM, you know you have to take pictures, and there will be so many information. For example, let's say the econ, the AHU, there will be so many information there. You need to type in this information one by one into the Excel sheet, and also verify that information is correct. So a student from the Infocom department actually worked with me and professor from Infocom to be able to use Python to be do a lot of programming to be able to get information directly from image. It could be PNG or JPEG. Take information from that and automatically populate it into AIR template. This is another way of saving time, using lesser resources to maximize outcomes, and that's all about improving productivity. Not just improving productivity, but productivity that gives value, and that's very, very important. And that's another topic for another day. So I just showing you here some extras and everything like that. For those of you that are very familiar with coding, you know obviously you work with far more than this. I'm just trying to give you some kind of flavor of the kind of work done by the student. Again, All this work were done by students. They were not done by me. I am just like a coach teaching Ronaldo and Messi on the strategy and everything like that. We've trained them, we've given them fundamental skills that they need. I mean, they need to be successful in the industry. And we are not just training them on those skills. We are actually giving them real life problems, because this is the only way you can learn better. You can know your mistake. You can also learn more from other people, from internet, but also from experts in the industry through interviews. So this is what we are doing to make sure that our students are job ready. Ivan, please tell me when I have about 5 minutes more, so I know when to.
Yes, there is only 5 minutes. Yes.
Okay.
Yeah.
So basically, our students, basically we expose them to real life problems, and whatever we've trained them, we try to use that to solve the problem in the industry. And with that, we try to make them job ready. So one thing is to teach our students to be job ready. That is, we call this one PET, right? Pre-employment training. So, but we are at SIT, our primary purpose, one, is to make sure our students are job ready, but also to help industry professionals and also companies. As part of our responsibility to Singapore, we also have our CET department, our Continuous Education Training Department, which we call SIT Learn. The purpose of this is to train people in the industry, because we believe in learn, unlearn, and relearn. We really believe in continuous learning. So my former student, Lojuan, for example, motivated me to have this course, because he works in the industry and he knows what is needed in the industry. He knows there's a need for people to be trained in the industry. In fact, PONG also motivated me. Both of them motivated. Okay, Prof, let's have this course for industry people. So I'm very grateful to them. So because of them, we actually developed this particular course called Computational BIM Information Modeling, Introduction to Dynamo for Revit. For some of you that are really interested to learn about this, you can register for this. And PONG also motivated me to also have another course apart from Dynamo, the one on Python, to further enhance the usability of the Dynamo for Revit itself. So we also have another one, and that will also be in December. So what we are trying to do is not only for PET and also for CET. Like I said from my topic, in creating workforce. Workforce, one, starting with our students, another workforce is existing workforce in the industry. What can we do to further increase their capability with regards to using computational skills to solve problems? And when we are training our students, like I said earlier on, it's not just about the skill itself, we give them real life problems. It's only when you expose people to real life problems you'll be able to make the best out of the training you're giving to them. Okay, so you can basically get in contact with me if you need some of these resources that I shared, and also if you have any question or you just want to connect with me, because I would also love to do applied research with some of the professionals there in the industry. At SIT, we do research with professionals in the industry for us to learn from them, to solve their problem, and at the same time use that opportunity to build the capability of our students, so that these students, upon graduation, they will be job ready. Remember what I'm saying? I'm not saying they will be experts. I'm saying they will be job. I believe from what I shared now, you see that these students, once if you have them in your team, it will be easier for you, experts in the industry, to be able to train them, because you are not training them from scratch. They have some fundamental knowledge, and they also have 1 year experience, and not just 1 year experience, an experience on how to use computational skills to solve industry problems. And a lot of my students now are very familiar with this, because they have to be familiar whether they like it or not, because their grade is at stake. So I will stop here now.
Okay. Thank you very much, Professor. Yeah, thank you
Okay.
very much. So I will just hand over to the next presenter first. If there's any questions, we will just continue during panel discussion, okay? So thank you very much. So I will hand over to Casey Ho from Autodesk with his presentation, Dynamo for DfMA.
Good afternoon, everyone. My presentation is not going to take too long. What I'm going to talk about today is how the computational BIM can help in terms of the DfMA workflow. Now, before I move on with my presentations, I just want to get everyone in the same page, just in case that everyone is not too familiar with the terms of DfMA. DfMA is the meaning of the design for manufacturing and assembly. Now, if you look at for the past 2 years in the industry, there's a huge demands in terms of the way how we conduct our construction approach. So conventionally, where we're using the bricks and concrete, we are moving that slowly away into a more to the lightweight concrete modules, modular constructions, and so on. The reason is because of the because it's faster, cheaper, and also because of the quality itself as well. So if you look at on the screen right now, this one is the image reference from Bryden Wood. If you look at the if you're looking at the traditional construction approach, from the site preparation to construction and to the work completions, it may take longer time. However, the DfMA approach is where you will move all the construction to the offsite, where you're going to fabricate your buildings at least 90%, 80 to 90% at the factory, and the remaining 10 or 20% at site for the installation and some of the core structures to be built up by using a concrete and so on. Now, if you look at the workflow of our the normal way of our construction, from the project brief of developments up to the post completions. Now, if you look at on these things over here, what I'm going to talk about today is not about how we can use the computational BIM to help you to design or to help your data flow from a stage to another stage, all right? But what I'm going to focus on today here is more to the tracking components, from the fabrications in the factory up to delivery to the site, installation, and also for the AN and FM. Now, this is one of the major areas where at this current stage or the current situation in the industry here is a lot of our fabricator and the main contractor are still focused on the manual tracking process, where most of the time they're using the pen and paper, and also they rely on their A4 paper or the A3 drawing to manage the data and so on. Now, if you look at on the on more details on the process itself, on the fabrication sites up to the maintenance site. So basically, they will go through a couple of stages. Now, from factory, after they have fabricate the modules or the component itself, they will need to load the modules into the transportations. And from the transportations, they will bring the transports to the site, right? And from site, they will unload into a certain temporary holding area, and they will proceed with the installations. And after the installation, they need to capture certain data for the maintenance or the liability periods and so on. Now, if you look at the current process, what is happening in the industry? I'm sorry, the screen is kind of a bit lagging, so it might be off from my voice. All right, so just bear with it. Now, if you look at from all these stages, from the prefabrications up to the liability period or the maintenance. So first thing first is when most of the time they might be using the Revit models and they will be transferring into a fabrication tools like Allplan and so on. Now, regardless to that, after they fabricate the modules and so on, first thing first here is they will start to do an inspection on the QA/QC. So I've visited a couple of the fabrications site or the factory itself. Most of the time they have a A4 paper paste on the module itself on the drawings, and also there will be a manual A4 paper to sign in and sign off. So the structural engineer, they need to sign off whenever they do an inspection. The MME guy will go in and do an inspection, and they will sign off at the A4 paper. So those are the way how they do the QA/QC and tracking in terms of the status and so on. Now, once the QA/QC is done, that is where they will load the modules into the transport or into the trailer or the lorry, so that it will be transported to the site. Now, after the transport to the site, most of the time here is before they unload the module and so on, they might need to do another round of inspection. This one is to prevent any damages during the transportation and so on. So those workers on site, whoever received the modules, again, they will use a pen and paper to check on the QA/QC or the inspection and so on. So if there's any issue, they will take a picture and then compile with their A4 paper, scan it, and then email it through back to the fabricator and so on. If there's damages or there's a crack line and so on. Now, the next thing here is if the module is in order, what will happen here is they will temporarily place it into a holding area while they will start to arrange it to do an installation into a certain location. Now, if you can imagine on at site, you might be facing 10 or 20 modules at the same time. Now, each of the module is specifically designed or being fabricated for a certain area because of the joints and also the orientation and so on. So it's very critical where you don't hoist the modules into the wrong location and so on. So the way how they keep track that here is there's a couple of ways. The easiest way here is they will use a spray. They will spray some of the coding, and the coding will be linked to the drawing or the detailed drawing that the site engineer is holding. So that's the way that how they manage it. And sometimes that more advanced site location here is they will have a QR code or the barcode so that they can keep track on the location and also the orientation and so on. So that is the way how they're managing it at site. Now, after they install at site, the next thing here is after the installation, again, they will start to do another round of inspections. This round of inspection to check the joint is in order, there's no leakage or there's no damage to the modules and so on. Now, all this data, it will be forward back to the main contractor for them to key into their model for the as-built model and so on, and also for their use for the asset management or the maintenance sites and so on. So basically, that is the current workflow that is happening in the industry. Now, if you look at the current workflow, there's nothing wrong with that. It's fast, it's quick, it's very easy because I have a pen and paper. I can just write, do some scribble, write some notes, and then send it across and so on. However, this kind of a method, there is a couple of issues. One is that in terms of the tracking status is very difficult because you don't have a proper system or proper single platform for you to manage the data and so on. Now, and also there is a risk in terms of the liability as well. So basically, all this is just based on the communication through email or maybe even through a WhatsApp chat and so on. So after 6 months or after a year down the line, you don't even manage to keep track or find back all the history or the communication. So those are the risks that is happening nowadays. Now, because of that, in the industry, there's a lot of systems or a platform for the fabricator or the main contractors to manage the asset tracking workflow. So from the data itself, where they have a system to do the QR code scanning or the barcode scanning, they keep track in terms of the modules. They keep track they have the BIM data in there so that you can raise the issue to the fabricator, and the fabricator can respond, do a barcode scanning to know where is the location. So they have all this kind of a system in place right now in the industry to have a single platform to manage that. Now, today's sessions, what I want to showcase here is we do have a platform, what we call as a BIM 360, to help you to manage all this kind of a manual process in a more digital way. Now, BIM 360, I hope majority of you here have seen BIM 360 before or been using BIM 360 before. Now, if you understand the way how the BIM 360 works, BIM 360 is good for you to manage the assets because you can upload your BIM models in there. You can keep track on the issue status. You can do the QR code scanning or the barcode scanning from there. However, there is a two major issue when you are using the BIM 360 itself is how you're going to link the fabrication models or the modular into the BIM 360 and how you can pump back the data that you capture at site back into your as-built model. Now, because of these two, I would say it's a broken link. The only way that we can manage to patch up the broken link is by using a Dynamo or the computational designs. Now, by using a Dynamo, I can link the Revit, I can export the Revit data into the BIM 360 assets, and whatever the data that we capture in the BIM 360 assets or the modular itself, we can use the Dynamo to regenerate back and push it back into Revit. Now, I will go a little bit details in terms of how we can do that. Now, for those who are using BIM 360 or have seen BIM 360 before, BIM 360 asset is a new module that in there happens in the industry that allows the customizations and also some sort of linkage to the Revit itself. Now, by taking this advantage and also a Dynamo, we are creating a link between the Revit and also the BIM 360 assets. Now, what we have done here is in the BIM 360 assets, we create a custom attribute. As of now, I call it as a Revit ID and also what I call as a FLC ID. So this Revit ID and FLC ID, I put it into the assets category, all right? And so that the Revit ID value will be used to store the element ID from Revit and also for us to push back the data back into the Revit element itself, all right? FLC ID, we created that for the future research and also the R&D purposes. Now, how we link that with the BIM 360 here is in BIM 360 we created the custom attribute, and in Revit as well we did some parameters as well. Now, in the project parameters level, we created parameters called B360 project ID. Now, we're going to need all these parameters so that we can build up the linkage and so on. Now, what is the use of the project parameter B360 project ID is for us to capture the BIM 360 project ID itself. Now, in BIM 360s, right, basically it managed by projects. So maybe in your firm or in your company, you have multiple projects in there. So basically what will happen here is each of these projects, you have a unique ID, and we're going to need this unique ID to be linked to our Revit model so that whenever we push our data, it will go to the right project, it will go into the right repositories and so on. Now, if you look at on the Revit itself, we do need a couple of more shared parameters to do keep tracks on the data and so on. All right. Now, if you look at on the data itself and so on, we do need couple of shared parameters so that we can capture, like for example, the QR code or the barcodes, installation date, the delivery date, when is the installations kick off, when is the installation completed, when is the warranty kickstart and completed, what is these serial numbers and so on. So we're going to have all these shared parameters to capture data in Revit itself. All right. Now, what we're going to do here is based on all these settings. The next thing here is where we're going to have the, oops, let me just push back. All right. Okay, so what's going to happen here is we're going to build a Dynamo graph so that it can push the Revit parameters and also that whatever the modules or the modular or the PPVC that you have in the Revit model into the BIM 360 asset itself. All right. So what we're going to do that here is, if you're looking at the screen right now, there's a couple of ways that we can export the data. As of now, currently we are still using the Excel or the CSV file formats to do the linkage. Now, the selection process, it can be multiple ways. Now, let me just show to you a couple of ways how we can capture the data from Revit into the Excel format. One is the manual selection. The first method is the manual selection, where the user are allowed to select certain elements, all right? And this method, we use a small Python script to filter out the elements that are not a family instance or the family are not related to the modulars and so on. All right. On the module, on the method 2 here is where we allows the users to select an elements model by searching for the instance or the same family and so on. So we search for the element and match the category so that the Dynamo can filter out the proper elements that we want to export into the BIM 360 itself. And on the method 3 here is we will find all the elements that are family instances. So there's a couple ways that you can do in the selection process. Now, as of now, the Dynamo graph or the scripts that we have done, we put in all these 3 options together because sometimes we do need a different methods to select elements in your Revit model. So it depends on the situations. So sometimes you might need to use method 1, method 2, and method 3. So at the center, we have added what we call as the method selector. So method selector is where we can control where the value will be picked up from. Is it from the method 1, method 2, or method 3? So basically, you can have a mix of it, or basically you can use their sliders to control it and so on. All right. Now, on the next step here is what I want to mention here is, I know some of you might be using the BIM 360 design. Now, one thing that is critical over here is during the selection process, the access path or the Excel data that you're going to export into, you need to pay attention. If you're using the BIM 360 design, Dynamo cannot recognize the path locations because your model is not in your local servers, but instead is in the BIM 360 itself. All right. So to keep the thing simple, the users is best to store the documents at the local drive and so on, so that it's easiest to manage. All right. Now, once that is, if you look at the process earlier on here is where we're going to capture the data from Revit, and we're using a Dynamo to push all the assets or the modular in your Revit model into the BIM 360. All right. Now, just a quick one in the BIM 360 assets. What you can do here is, one is the BIM 360 assets will help you to manage the documentations, or they will centralize all the documentation. So whatever the modular that you have in Revit, basically will be part of the assets in the BIM 360. So you will be able to see there's a list of assets, not only on the PBU unit or PPVC, maybe some of your fabrications on the M&E models, or your ductings and so on as well. So basically from here, you will be able to quickly access all the assets, including the warranty data, the QR code, the link, the purchase order, and all the relevant parameter that you have in Revit itself. All right. Now, the next thing here is we're going to use the BIM 360 assets to manage or to control the status. So basically, if you're looking at the modular construction itself, basically we need to keep track each of the elements or the modular when the modular has been ordered, delivered to site, installed, and have you done the QA/QC, and is it accepted, or the warranty has been kickstarted or anything. So basically, the status of each of the module, it will the BIM 360 allow you to customize that. So basically, you can customize whatever the status on the each of the assets and so on. Now, at the same time, we do encourage the fabricator to paste or to link each of the element with the barcode or the QR code. So the QR code is the best way because you can easily generate the QR code from any kind of a free tools that you have in the industry. So by just scanning the QR code on site, I will be able to know the assets or the modular, where is the locations, and what is the status for that modular, and the modular is linked to which area or which zone, how is the installation, how is the joints and so on. So the QR code is the best way to link all this kind of data, especially whenever it's on site. Instead of going through all the paper and so on, it will be able to do that. All right. Now, at the same time as well, in the BIM 360, I just do a quick highlight over here is if there's any issue happens on the installation or on the modular itself. All right. So basically, you can raise the issue, send it back to the fabricator saying that, hey, this module has a crack line or the joint part have an issue and so on. So basically, you can communicate that with the BIM 360. You can take a picture and send it across, and also you will be able to do the QA/QC testing or the inspection directly from the BIM 360 itself. All right. So basically, everything can be done digitally. All right. And the last thing here is where you can start to update the status of that module. Like for example, when the installation is done, by who, by when, what happens on. Now, we need all this data to be pumped back into Revit for our liability period, for the SBIP model, and also for the assets management in future. All right. Currently, as what the industry is doing right now here is, we will have a BIM coordinator sit in the office 24/7. They will start to key in all this data manually back into the model. Now, by using the same method, by using a Dynamo, we will be able to push back the data into the Revit itself. All right. Now, if you look at over here, basically from the BIM 360 assets, we will be able to manage to export the CSV format or the Excel format. All right, with the right attributes or the contents or the data from the site. So what will happen here is we will use the CSV data, and by using the same code with the link with the Revit ID, so basically we will be able to push back the data back into the Revit itself. So by using the Dynamo, we will be able to do a linkage and to automate the process from the fabrication models to the sites, and from the sites into the asset management or the facility management. All right. Now, just a quick recap before I end my session is where basically by using the Dynamo and also the BIM 360 in the workflow of the DfMA, So basically, you will be able to see that the process will be more streamlined, and also you have a quicker resolutions between the stakeholder itself. So if I have any issue on site, the fabricator will be know a minute right after I raise the issue. They will be able to immediately respond back to you, and you can continue the works on site. And this kind of process, it will be beneficial, especially at these current situations. Because of the COVID-19 and also the pandemic situation, we do need to work remotely, and we need to communicate virtually to streamline the process and so on. And also the visibility of the project status will be very significantly improved, because everybody will be aware or have the visibility on what is going on site and what is happening in the factory and so on. All right. So, and I will be ending my sessions right now. So if anyone have any questions, post it in the Q&A tab, or we can take up the questions towards the end of these sessions. All right. Thank you, everyone.
This is Mark. All right, I represent my company, Freeform Solution. So today I just want to share with you something simple, something fun, but not so intense. Okay, this is what I do practically most of the time. Okay, I do a lot of Rhino in my office. We do some consultation, we do training, we do sales. I'll show you what else we do. So this is just a very recap of what we are doing as a company. Freeform has been around for almost 15 years. We do 3D printing for SLA. We do mock-up study on CNC. We have routers that we do our own prototype for customers. For the past 8 years, we've been going into 3D scanning and CADing as well. So Rhino has always been our platform. I use AutoCAD too. I use Revit in some way, but then I have to say I use Rhino for a lot of my own other tools, because initially the years we started with product design, and Rhino started in 1992, and then once it moved to architecture, it has been almost 10 over years. So Freeform does all this, and we have a good team of folks that's supporting each other. So I want to excite you with more pictures, but then my presentation will last a fair bit, and then after that I want to go into the CAD space for you. All right, so this is an example that I was trying to read up last year, and then I saw a lot of videos about the Morpheus Hotel and by Zaha Hadid. So I saw the whole constructions, and I was trying to learn what they do as well. And knowledge is really good, because everyone shared their pain as well, pain story. So I like this video. If you want the link to all this video, it is all in the Rhino website as well. It's a long part series, but it's good to see how the fabrication is done. All right. So give you a head start. Rhinoceros 3D. Yes, most of us in our office uses this now. Sometimes we call this Rhino, and sometimes we call it Rhino 3D. All right, so in general, it is today, you focus a lot in architecture trades, industrial design. Some of my colleagues does that. And a very small part of us are involved in jewelry design, assisting the local people, trying to establish some of their design pattern. So I felt that the only tool that it's pretty in between most of the software would be this. However, we find that because there's a continuity, take for example the prototyping part, it has a very good meshing tool as well when you export. We as well helping some of the companies that does shipbuilding as well, engineering design, and of course 3D scanning is our recent little toy that we have in the office. So just to give you a high side, it has been quite a big community over the years. Obviously it is not huge, but then it's big enough, okay? And it has been a platform that a lot of us share. So sometimes the main thing is if somebody asks us, do you know what can this do or what can that do, we sometimes if we don't know, we will jump on the wagon to our Southeast Asia friends and ask, hey, do you have sources that we can share with our customers? So most of the know-how is shared within the community. Nevertheless, the fun part is everybody is trying to learn from each other. So the multi-platforms in terms of website, all the different Rhino link that is possible, everyone is using it. And occasionally we have meetup. The meetup is basically hangout, you know, not much like an official meeting, but it's more like a user just chit chat and then eat and drink. So the next slide that I want to show you is this. So how extensive over the years for architecture? It has probably 12, 15 years already. I don't really know when the transition starts. We started seeing the pattern happening definitely more than 10 years. But then from product design, there was this big transition. Initially, wasn't very sure. A lot of people wonder whether Rhino can take on architectural design. Obviously, we cannot do all the BIM. We are not here to do complete BIM, and we can't compared to what Autodesk is having. So, but then the initial part, I guess most of us are comfortable with the know-how, and it's fast enough to execute. Well, at the same time, it's accurate. So I know we have NBBJ just now sharing, and one of their projects sample is Hangzhou Stadium. I guess we didn't talk about this one, but then this is one of those things I was following, and then I saw the proposal, and it's pretty impressed with the whole entire Grasshopper and Rhino integration. We can do from start to end. However, there will still be a lot of tools that we need. So Rhino and Grasshopper is more like it's a very open source community. So sometimes people write certain things for each other. Okay, of course, architecture firm, if they have some little know-how internally, like their own software developer, then they have that little secret weapon inside. But the general tools, yes, most of us will be able to handle. It takes time. It really takes time. I've been talking to a lot of other users. Everyone loves to jump on the wagon. However, the difficulty is really spending time to understand the whole workflow. Of course, this is our famous jewel. It is also done in Grasshopper, the whole entire modules and the execution. So programming is done. The structure guys did the whole entire Grasshopper thing. So I'm pretty impressed. I saw the code as well. The definition is really long. Right, so Waffle's structure design, I was just talking to some of the customers the other day. I mean, I just brought this up because some of them were asking this question, and I was thinking, what do I put in these slides? You know, just sometimes just too many information and you're trying to piece everything together. But then I thought this is fun, you know, this is something that is, for me, it's quite, it looks simple, but then obviously I believe to build this, it also has its own challenge. So I was just pulling off some of the slides that I saw, and I thought this is nice. Okay, so for the Rhino part, it is pretty straightforward. Grasshopper perform most of the sectioning. Okay, and then of course production can also be done here. But this, I believe, is also the initial phase of studying the mock-up, translating this into a basic prototype. So in our office, we have laser machine. So we use, I mean, obviously this is not done by us. I'm saying that sometimes when we finish certain waffle structure too, we will perform the cutout and then study it. Not so extensively. Sometimes we just build it smaller just to get it done and, you know, to see how is the effect of. So students learn through this as well. They finish it and using the laser to cut all this out. So they have the understanding of trying to fabricate probably on their back end. So I know the topic is what is Rhino.Inside.Revit. Just to give you a hindsight, if you know Rhino or you don't really know Rhino, Rhino.Inside is a word, like it is a statement now, okay, officially from Rhino team. Rhino.Inside, it is a term now, it's going to be used. So it could be, example, Rhino inside Microsoft Word. Okay, so Rhino inside something else, Rhino inside Adobe. So Rhino inside, it's a term now. So officially, McNeil, which is the Rhino team, decided that this is the word for this tools that is going to be used. So this is probably my longest text here. So in hindsight, it's a new technology. It's embedding technology between two platforms. So the insight will do other exploration. So it's a linkage. Basically, it's intermittent between handling the files between both softwares. Right, it's pretty straightforward. And why did Revit becomes part of the whole integration? Because earlier on, when we does Rhino exporting to BIM, we have some challenges, right? Unfortunately, most of the file that goes through sets or or DWG, sometimes it fails. So the Rhino team decided that they should invest a team of developers creating this whole entire Rhino inside something. So Revit obviously is top their list, and some other tools that work with, right? So practically this is what it does. So this is the baseline for Rhino. And when we use the plugin, the grasshopper is sitting inside from the platform of Rhino. And of course, the plugins that all hop on to Grasshopper, and then they all, one big family, and then they try to do everything within this capability. So just to share with you, if we have rhinoceros, we have flamingo, we have bongo, it's all animal. So now we run out of name. I don't know, we haven't got giraffe, and there's pufferfish, there's so many names. So the funny thing is, if they call it the network drive, there's a name. We call it the zoo. So the zoo handles all the capacity of licensing. So you will start hearing us saying cloud zoo, cloud this, and so zoo is the network terms for Rhino. So after Grasshopper within Rhino, there's a transition. Okay, so Rhino Inside will start getting all the information and into Revit, okay, and then obviously Revit can goes back to Rhino, and Rhino the other way. So it just keep doing this information. So I can update in Rhino, and then Revit is updated, right? So if I continue my design in Rhino, Revit gets updated. So this little link is, I see that it's very, very helpful. Obviously, I do not use Revit that much, I have to say. I do a lot of Rhino, and I realized that if I need to get the file to some of my customers, I will do this Rhino Inside for them. They find the files really clean and is usable for them. And I try to make sure that they get a good file. So this is how the interface look like. This is how, on the background is the Revit. Rhino is sitting on the second layer, and then followed by Grasshopper as the final layer. So what the Grasshopper team did was they did a definition to translate Rhino to Revit. Basically, that's the arrangement. So this is another slides that I pull off, and then just to show you the transition between these interfaces. Digital fabrication, big word. I have to say, really big word. I think we sometimes, I think even doing this sort of transition is also a big word, and I also known that this is probably digital fabrication this way. I will do a demo. I think a demo is more interesting. So I will change my slide. Just give me a second. I will want to run my sharing. Where's my sharing? 1 second, please. Okay, I'm going to minimize my slides. I want to share. Yvonne, I off my slides, right? So I stop share and I share again.
Yes.
Okay. I want to run my. Okay. Confused. 1 second. Share. Want to Windows, yes. Okay. Can you see the Revit software?
Yeah, we are
Okay.
able to see your Revit
Okay.
and your webcam. Yeah.
Yeah, thanks. Okay, so not gonna take a long time. So basically, it's two things. So I'm gonna go new. Okay, everyone are very familiar with this. I have all the Autodesk folks here. Okay, so I start the Revit. Okay, so the add-on is basically there's a. I don't know why my screen is flickering, but anyway, I will turn this to my 3D view. I don't know, it's flickering. Okay, doesn't matter, I'll just carry on. All right, so the add-on now, there is a Rhino work in progress. So this work in progress doesn't sit with the current Rhino. This is the next generation Rhino. So Rhino Office has released this basically for all the Rhino.Inside performance. All right, so this probably will be Rhino 7. Okay, so in the future, the current version is version 6. So in the future, it will be Rhino 7, 8, 9, and our version comes really slow. So this is work in progress. So I will launch my Rhino. All right, so you see a background of the 2D sketch. Basically, I've on it. So just now I was trying to make sure that all the link works. So this is my Rhino platform. Okay, I drew something just now for fun as well. Okay, and then this is my grasshopper. All right, so there is three platform. Basically, this is the Revit. Second tier is the Rhino, and this is my grasshopper. Okay, so what I do is every time if I need to do a link now, let's say let me pick something this. I don't know why it's flickering, but okay, so let's say if I select these guys. I'm trying to, one second, I'm trying to make sure that the Rhino plat, it's let me close everything. Just let me close everything. It's flickering. Okay, so I will start again. Nope. Close. I will launch my Revit. Do I need to share, or can you see the screen now? You can still see the screen?
We are seeing your webcam at the moment.
Okay, let me yeah, I will
your
change
face.
my face.
Yes,
Don't
it's
see
like
my face.
But it's okay, we can wait. So later
One
you
second,
can share again. No problem.
Really fast. It's launching, and I promise you will see that in a second. Okay. Okay, you see the platform, the software?
Yes, Revit. Yeah.
Yeah. Okay.
Okay.
So new, back to this. Back to architecture. Okay. So Revit starts. Okay, done. Okay, add on. I turn on Rhino first. I will need to turn on Rhino. So I run the Rhino platform inside Revit now. Okay, that means I can do all my modeling with Revit minimized if I want to, in that sense. Okay, so I turn on my Rhino. Okay, so my Rhino platform is turned on. Let's assume I pick the model that I was trying to showcase. No, just okay. So this is the Rhino model. I will turn on the Grasshopper. Grasshopper is my translator. It helps me to translate my Rhino informations to my Revit information. So this is what you see. I'm just going to view. Let's see if it's in 3D. I know it's flickering. It's interesting. Don't know why. Okay, so if I have to, let's say in any circumstances that I need to update my Rhino, okay, I'll scale this slightly. If I zoom in now and if I do an update, say if I pull this up, it's live. Right, so this whole link now is completely live. So every time when I adjust Rhino, it will help me to, because I have a dual screen, so I need to find where this is. So if I were to move it up, everything will be live. So this helps me to just draw everything in Rhino now. So if I need to, sorry, if I, let me just change this. In any circumstances that I want to perform a new sketch now, just draw really something live, okay? So draw this, and I turn on my points. All right, so I go to my perspective view, and maybe I just do this. So this is some canopy that I want to illustrate, and then I'll do a quick surface network. Okay, so this is something that I think, okay, that's quite cool. So done, and if I want to translate, I will do this. If I look at my Revit, there's nothing there. All right, so but then if I tell the grasshopper that this is a new component for me, just separate one so that I can differentiate. So I will copy this component. It doesn't need copy now. Okay, copy and then paste. All right, so this one I will pick on the new surface model that I have. All right, so I will connect this basically to the generation of the tool. So in actual fact, I should see this updated in my Revit. Done. Doing quite badly. So if I have to, then this will be something that I can work with back and forth. And nevertheless, if I delete this, I need to, or maybe I move this somehow, accidentally I move it. So in my Revit model, it should also be updated. Yeah, so it's all updated. So within this boundary, I could probably say, we can just keep doing my Rhino and then keep my Revit there without actually moving between too much of the model export and import. Previously, we tried to export all this into sets. We try to export all this into the format of sets, but sometimes the file doesn't really get converted well, and then Revit facing some problems. Then the workflow becomes an interruption for a lot of users. So now this.
Hello, sorry.
Yes.
Hi, Mark. We can only see Revit at the moment. You are sharing the Rhino as well?
Yeah, I'm sharing a Rhino as well.
I think you only selected the Revit earlier, so we only see the result in Revit. You're
okay.
sharing
So
your screen one. Okay, okay.
Let me share again. Yep, let me share my screen.
Yeah, we saw the Revit result.
Can you see this now? All this?
Okay, now we are seeing Rhino at the foreground and the Revit at the back. Yeah, the grasshopper. Yes.
Yeah. Okay. So I'm just sharing with you the format. It's not so. Yeah, I was just talking about format. I got lost there. So the format got some problem with the workflow, and eventually some users just decided that okay, it is really cumbersome. Okay, so this Rhino.Inside has now stabilized the whole entire workflow. So if I again shift, assuming I shift this back to this point, okay, so the update will be natural. The update will be back to Revit itself. Okay, and then of course, if I need to perform the task of updating, can you see my Rhino now? Sorry, I have to move between screens, so I just want to ask you, are you able to see my Rhino?
Yeah.
Okay, so if I build more components, assuming I build some more components, within this space. And I'm going to copy what, sometimes I decided that these being done simple, because if I delete it, I will not mess up my own collections. So now this new icon will collect all these folks together, and I will bring them into this. So my Revit should be updated with the new bounding area. So within this ability, it is a lot faster. The file size are smaller now in terms of exporting and importing. So it does help a lot. Okay, I know this is a very brief introduction of what the tools are. Rhino.Inside is still work in progress. So I don't know when and how everything else is going to come together. There's no deadline. Rhino is very flexible about their deadline. So we just have to use it, and it's free. So if you are a current user of Rhino 6, this is free for you. You should be able to download and then do your transfer immediately. Okay, if you have questions how to do this and how do you install this, I could just advise you how to do it. So I am open for questions, Yvonne. Otherwise, we can move to the next speaker.
See the screen now?
Yes. Okay, you can start now. Thank you.
All right, thank you, Yvonne. Okay, so we will be the last presenter for today. And I'm actually Jaziel Magdadera, and I'm representing ONG&ONG. I am from the digital technology team in ONG&ONG, Singapore. And what we basically do is we assist the teams, we train them, and also we help them implement not just their BIM software, but also other software that will help them optimize their workflows or make their processes and standards better. Okay, so for today's session, we will be sharing some of the few projects that we've been doing with the teams. So there will be the designers, and we are just there to assist them do all of this computational BIM stuff, okay, alongside training them as well as we go along. Now, in a few of the events that we have been to last time, and in I think the first event or sharing session of this computational BIM group, we have done a few sharing as well. And as you can see here, for consultant side, we lean more towards the form of the building during the conceptual stage of the project, and also design optioneering. So basically, the last time we presented this Pile of Our Church facade, we were talking about as you see here, the facade panels and changing the rotation values relative to its location and the sun's location. And we also have this interior design from Vietnam. We were using like a sine wave algorithm to create this wavy organic ceiling. We also had a few projects such as the Adobe Public Library, a condominium, Whitehaven condominium, and also we explored our first exploration of generative design using, I think, yeah, that was Project Fractal back then. Okay, and this one was our entry for the Archifest Pavilion competition in 2017. And then after that, we, I think Project Fractal got stopped, but it was replaced with Refinery. So we explored Refinery and had this conceptual tower in Malaysia, PJ Central. We were exploring on the different facade options as well, and also the GFA of the tower. All right, and of course, as consultants, we also have to create documentation drawings. So aside from doing all of this conceptual stuff, we also create some sheets, right, for submission purposes, for construction purposes later on, sorry, for tender documentation purposes. And so we all know as well that Revit, as good as it is now, it has its few limitations, as well as, well, other softwares have their own limitations as well. And that's why it's quite good that we have Dynamo to bridge all of these gaps. So we were able to create mini scripts as well to help our teams make or do their tasks more efficiently, such as the most popular one here that we see everybody is almost using is the batch duplication of sheets. I know if you're a Revit documenter, or if you do sheets in Revit and you have to duplicate, you'll know exactly how tedious that task is at the moment if you do it manually. So by using Dynamo, we actually created this script that will allow them to duplicate the sheets along with the views, schedules, legends, and whatnot inside that sheet, and also rename everything. Aside from that, we have other stuff that you can see here, and also project setup and maintenance, such as, for example, there are some beginner Revit users who still imports AutoCAD files, and thus it also imports line styles and other stuff. So we have some scripts that will help us clean up the Revit files. And also we have RLS, RDS stuff for MOHS projects, most especially, and a few other things. All right. But for this session, we'll be sharing, just like what Mark shared, we'll be sharing something that is not too complex, but is quite fun and helpful for us as consultants. It served the purpose. It helped us achieve our goal. All right. I'll be starting with 2 projects, and then later on, I'll pass this presentation to my colleague Arthur, who will be talking about 1 more project. All right, I'll start with this first one, which is a residential project. It's not in Singapore, but it's still in Asia. And so the team here have already computed for all the necessary areas, and they have determined that for residential area, they will have to use over 100,000 square meters. Okay, and the floor layout, they wanted it to just be around 900 to 920 square meters. The footprint would be 32 by 35 meters, more or less. And so going by that floor plate, right, and the residential area of 112,600 square meters, there will be approximately 120 floors. And their option is, since 120 floors is too high, their option is to divide it, split it into 2 towers or 3 towers. Okay, approximately, if it's 2 towers, there will be approximately 60 floors. It's 3 towers, and there will be 40 floors. Now, they also wanted to just play with 1 single floor layout. Okay, there will be just 1 typical layout through all of the floors. And so the concept for their plan is...
Jess, sorry. Do you mind adjust your mic, because the voice is very soft now?
All right, sorry. What about now?
Yeah, it's better.
Okay, I just have to lean a little forward. So the concept is that they wanted the core to be in the middle, right? And the units to be surrounding the cores so that they can maximize the view. Okay, and also they wanted to add some interest, right? Visual interest to the plan and later on to the facade by adding these recesses at each corner. Okay, and this one later on will then be the sky terraces. Okay, and the floor plan that they created is this pinwheel plan. Again, this is going to be typical across all levels of the tower. And so if we actually stack them together on top of each other, for the typical or the traditional layout with the core in the middle and the units surrounding the core, it will look like this. It's just a huge block of a rectangular building. And adding the ventilation gaps or the sky terraces, it will create this recess on the facade. All right, but still it looks not too interesting, right? To make it more interesting, of course, the team added some features such as balconies of different sizes, such as this, for each floor. And to say maybe randomize it, they were thinking they want to still have the same floor layout, but they want to kind of create more visual interest, maybe make it more random a little bit. So what the team has decided is there will still be the same floor and number of units for each floor, but then they will flip the units, just as what you're seeing right now. The core will still be at the middle, the units will be flipped, and so you'll see that the sky terraces here, okay, or the ventilation gaps, from the original plan is on the left side. On the other plan that was created after flipping, it's now on the right side. So this will happen, and you will see if we stack it together or on top of each other, there will be recesses at varying areas of the building, and that was good enough for the architect to create a visual interest. Now, if you are just you already know how many floors you want and how many stacks of these floors you want, then you can just go ahead and do it in Revit right away. But for us, we wanted to explore more on the different stacking options, right? We don't want to just take with 10. We wanted to explore what if there's 5 of each floor and then alternating every 5 floors, or what if we want to randomize it? How many randomized options can we have? And so this is where we actually tapped Dynamo to create. So I'll just be showing you a short video on what we've done. Basically, we created 2 modules here. At first, it's a generic model because we only want to see how it would look like in the exterior view or the facade, right? And the user or the designer will just have to input the name of those modules here. And then they can adjust the number of floors and also create this randomized module location is basically creating several randomized options. And the third one would be the designer is able to say modify the ratio. So for example, they want 40% of floor plan layout 1 and 60% of the flipped layout. So they are able to control that as well, while also randomizing the locations of these floors. So as you can see, just by sliding, they are already able to generate different options there. Okay, sorry, back. Yes, and then later on, we decided to add another option for them to create vertical clusters or to divide them according to the number of floors. And so we have this other option that you see here. And what they can do is they either, if they want to randomize, they choose 1 on this slider, or 2 if they want to create vertical clusters. They can change again the number of floors. We also added rotation for the orientation of the building relative to the site and the height of each floor. Okay, so here under divisions, they can specify the number of floors. Alternating floors for each floor module. So this one, 20, and then we decided to change to 5. And well, it's quite fun to play with. At least for me, it was fun to play with. I was able to create a few options, and once the designers will then decide on what they actually want to go with, I imagine the next step, although we haven't done this step yet, the next step would be to create this as a group first and then place them. Once the designer has decided the layout, then they will then have to add all the building elements only once, and then it will change all of the floors in this building. All right. So this is for this project. Yes, it's quite simple, but I believe it actually served its purpose, which is to explore on the different facade options based on the modular floor layouts that they have. Okay, now the next project is, well, this is actually a small one, and this is also about modules. Sorry. And this is for our existing level 9 lobby in our office. So if you've been to the ONG&ONG office at level 9, you'll be greeted with this hello symbol when you step out of the lift. Okay, and we were looking at replacing this with something modular for the entire ceiling. And so we have come up with several options, such as, well, the one on the left is basically, you know, module panels along curved surfaces or a curved ceiling surface. And then the one on the right is still rectangular modules, but with a more randomized look. Okay, and these will be pixel based, based on a certain image. Now, I'll be talking more on the second design, because I think the first one is a little bit too common to do. This one, although it's quite simple, it can take you ages to do in Revit. And so we also use Dynamo to help us do this almost instantly with every single image. Okay, and I'll be showing you how we're able to do that, but let me just discuss the concept a little bit. So of course we wanted a randomized look and made of modules just like this, but even if it's randomized, we want to say that it's not actually randomly placed, because it's still based on an image. So if you actually look at it from a certain angle, you'd see what is the base image. Okay, and to do this, of course, we need our own image that we want to use as a base. And then from that image, we then divide it into pixels. And the size of these pixels will be based on the modular panels that we'll be using for the ceiling. So for this one, it's 150 by 150 mm panels. So we divided the image into these sizes of pixels. And then based on these pixels colors, we then get either the red value or the green value or the blue value. For this script, we decided to use the red value, so it's all consistent all throughout. And that red value, we then mapped it to the maximum and the minimum offset values from the ceiling, or the distances of the panels from the ceiling. Okay, so that's why it will create a visual interest by adding depth to each of the pixels. If you look at it from the section view, you'd see that each of these panels, individual panels, has their own offset. Again, this is driven by the pixel, the color values of each pixel of the images that will be used. And so throughout the year, if the office wants to use another image, then we can just play this and create the documentation to check which panels needs to be adjusted. Right, and this is how the script looks like. Again, it's very simple, not too complex. This is how far I can zoom it in. Basically, the user input, the user only have to select the ceiling. This one, we selected in the model, the ceiling of the lift lobby. And then the user will have to specify the size of that room, as well as the dimension of the pixel or the modular panels. And then, of course, the user will have to also add the image that they want to use. And this minimum and the maximum distances from the ceiling. Right, after that, it will, in Dynamo, it will just create this series of panels, color-coded panels, and we then push it to Revit here in the script using the RGB values and mapping it to the offset values of these panels. These panels have offset parameters so that we can actually control them. And while playing with several different images, right, this is how it will look like still in Dynamo. And pushing into Revit, these will all have one single color. This is another image. So basically, you can just change by using one click of a button, just download an image, or if you have your own image that you want to feature, the designer will just then have to upload it, put it here, and run. And lastly, for documentation purposes, we also were able to instantly create a color-coded ceiling plan with each panel's offset value. So for example, here, orange panels are 160 mm off from the ceiling, and 200, and so on. And by using the script, you are not going to be doing it manually, right? Because good luck, if you do this manually, it will take you a while to finish everything, especially that there's just 150 by 150 pixel panels. There's probably 1,000 of these panels on the entire ceiling, or hundreds. Okay, so yeah, these were two of the projects which we have played Dynamo with, which served its purpose, gave us what we want to do. And so I will be passing this presentation to my next colleague, Arthur, for the projects that he's worked on.
Okay, thank you, Jazel.
Thank you.
So I'm gonna hand over to Arthur now. Just give me a moment. Okay.
Can everyone?
Okay, Arthur, yours up. Yeah, your turn. Yeah.
Hi, good afternoon, everyone. I'm Arthur from Digital Technology team at ONG&ONG. Today, the last presentation will be very short. I will be just presenting a solution that we come up to resolve a problem using Revit, native component, and Dynamo scripting. The challenge that we have in this project is to create a seamless facade element that is dynamic. In a way, we're trying to strike a balance to the opacity of the facade. We wanted to create a facade that is visually open in certain places, such as in public corridor or escalators, and gradually closes in certain areas, such as back of house or the machine areas. The main challenge of this project will be have to gradually open and closing between these areas and to create design option to produce the most optimal design result. Although it is possible to do this manually by setting up each facade panel individually, that will take a very long time and very time-consuming process. It will not be adaptable to any design changes. In this study case, we'll be using computational tool to help us to answer to the challenges.
Hello, Arthur. I think you are muted.
Ooh.
Hello.
Yeah.
Yes. Yeah. I think maybe can go back a few seconds. Yeah.
How many?
Okay, now we can hear you. Yes. After this one. Yeah.
Where did I stop?
The introduction. You're done with the introduction. Yeah.
Okay.
After this slide. Yes.
Okay, first we need to create the very adaptive facade element. This facade element opening is controlled by a single parameter that will adjust how wide it will open and close in the project. So this we can see by adjusting the controller, we can have the facade element open and close. Okay, the second we populate the facade with the adaptive panel element and flex the panel opening panel so it can close and open. Also by adjusting the controller by a single number. So far, this is a very manual process. No need computational involved to be involved because it's controlling every single panel in the facade. The next step is we want to have a controller that can affect the way panels are open and closing. This controller can be a point, multiple points, line, or a curve. For today, we'll be using an arc to control the facade opening. So this is the arc that will control how the facade is going to be open and closed. So the closer the panel to this line will control how wide the opening of the panel. Each point of this line are parametrically adjustable using the software tool. This will help the designer to fine-tune the design of the facade. The last step will be to connect this arc. Last step we connect this arc to the facade element. The software will calculate the distance within the line and each panel and adjust the opening automatically. So we can see I'm playing around with the arc shape. Whenever I change the arc shape and location, the opening will be adjusted to the facade. So although it's possible to do this manually, I think it will be a very time-consuming process. The tools that we have will help designer to fine-tune the design and help to make the design decision faster. I think that's all from me, Yvonne.
Okay, yeah, thank you. So let me share my screen. You can stop sharing the webcam and thank you very much, Arthur. Yeah. So, okay, just give me a moment. I will open this one. Yeah. Okay, so everyone, now it's a panel discussion. All the presenter will unmute their microphone. Now, we know that this webinar, you can only raise question from the Q&A panel, right? So you're welcome to share the question there again. And all the presenter can just jump in to answer it, okay?
Hi, okay, I'm Daniels here from ONG&ONG. Maybe you guys can hear my voice, right?
Yes.
It's okay, right?
And
okay.
I can share your webcam, Daniel. Yeah. So they'll be seeing the slide and your webcam.
Just see the slides. It's okay.
Oh, okay.
Share my webcam was okay. Fine.
Oh, okay.
Okay. So afternoon, everyone. Okay. So we're going to start the panel discussion now because now it's already like almost 5 o'clock now, right? Okay. I think Ash is no longer online, right? Because I think it's in US, so it's like 5 o'clock in the morning. It's very late. I mean, it's like
very early.
Yeah, very early. Sorry. Yeah. Okay. I mean, let's recap. Okay. I think Hash did I guess very good sharing to us, right? I mean, the fact that design can be started using data. So he's using data a lot, as in gather all the infos about environment, all the all these data analysis, and create the forms from there. I think that's and it generates sort of like a generative design kind of process, right? I think that's it's fantastic. I mean, that kind of process. I mean, I hope there are more projects that can explore that kind of approach here in Singapore. Okay. Yeah, I mean, the thing is, I guess a lot of this is perhaps mainly focusing on the early stage of the design. So I'm not too sure because actually I was about to ask whether the how this thing affect other discipline, for example, right? When it comes into more when the design is more refined, it's more confirmed, things like that, right? So it's and how this computational or data analytics that he actually done actually connect to the other discipline like structures and M&E and so on and so forth. Right? Yeah, so that's probably my questions to him, but unfortunately he probably can't join us now. Okay, that's right. Maybe we move to the Professor Moshood. Professor, are you online now, right?
I'm still online. Yeah.
Yes, online. Yes. Sorry, your I think your mic is a bit too far. Can you hear me? Yeah. It's slightly better.
Okay, do you have question for me?
Yeah, okay. I understand that your students
Daniel, we can take.
There's a feedback. Yeah.
There's a lot of feedback. Is it okay now?
Yes, it's okay now.
Okay, yeah. So for M&E, right? I mean, I'm just sharing in our practice, for example, a lot of our M&E guys, I mean, mainly they wait for the RT model to start first, right? I mean, wait for the structure model or BIM model from structure, BIM model from architecture to start. Then they can start the M&E. So how do you resolve this in your course where the your team or your students pretty much single disciplinary, I would say, and or have you also explored the collaborative process with other faculties, with other, like, for example, Archi students or CNS student or structure student, that kind?
Oh, thank you very much for your question. At the moment, our program is building services engineering. So at the moment, we don't collaborate with civil engineering, for example, and we don't have architecture program in my university. So in the case of my students, we train them to do the Archi themselves. Then from the Archi, they move to MEP and do the MEP. I shared just now my design studio. In the design studio, I gave them an assignment brief. In fact, I took them to sites where the building is supposed to be, quote and unquote. So from the assignment brief, the student designed everything from scratch, because in fact, I had to teach them bubble diagram. Do you get what I'm saying? I took them through the architecture training because I'm an architect myself. I'm also at the same time a chartered engineer. So I can switch from Archi to MEP. Do you get what I'm saying? Because I'm a chartered building service engineer. So at the moment, my students actually did everything themselves. So they did the Archi and they now move on to the main thing, which is the MEP. So in practice, how would that work? So let's say, for example, my students are in your company, for example. They will understand some of the things the architects are talking about in terms of how to use the Revit to do some architectural drawing. Of course, architects will design, they can help. But the MEP part, then that is their main area. But in training at SIT, we also give them architectural training, because at the moment we don't have Archi department to be able to do that kind of collaboratory activities. So I would say in a good way, but they are experiencing the Archi flavor also. But they are MEP students, building services. I hope that answers your question.
Yes. Okay. So, but they are not designing the building in the sense, as in the architectural design, right? How do they draw the actual building? I mean,
they design it.
They can put an Archi model, but do they actually do design exercise at the same time?
Yeah, they design from scratch. For example, they design condominium. So I went through with each of the students the design philosophy. We went through some bubble diagram. From there we went to sketches. From sketches, once they finalize the design, then I give them approval to move to the Revit themselves. So I always tell them, don't go to Revit first, you have to design first. So they actually went through the architectural kind of training. So I use my architectural cap in that sense to give them the architectural training. So they actually design from scratch. They design the building. I didn't give them the drawing. I didn't give them any flop. I only gave them brief. So they actually design from scratch, starting from bubble diagram, to sketches, from sketches to now going to the Revit to model it out.
Oh, okay. Wow. So they study architecture as well as but their degree is basically mechanical engineers,
correct.
Right?
Yeah. Correct. Okay. And you're right. This is not common because their professor is an architect also. I'm an architect, and at the same time, I'm also an engineer.
Yes.
So I use that opportunity to provide that kind of training to them. So I gave them my architecture training because I've coordinated a lot of studio before. So I took them through studio kind of training and everything like that. So that is why we call it design studio. So in fact, it was very stressful for them. They learned a lot of things, architectural skills. So I told them to be useful for them in industry although they are not architects, but at least they will be able to understand what architects are talking about because they've gone through the idea of designing. So whatever I showed you just now, the students actually designed the archi themselves. After designing the archi themselves, they now went through the MEP and designed the MEP also themselves.
Okay. All right. So I guess, okay, good. So my next question is, okay, so again, based on our industry experience, right, this so-called computational design or computational BIM user, which is mainly kind of a group of people which is lesser than the BIM user. So, okay, so if you take a look at the overall staff kind of strength, for example, right? Okay, so from overall staff, from the archi, so-called designers and architects, for example, right? For example, we have hundreds. So the one that using BIM perhaps is much lesser than that. Say maybe like, just assume maybe 80. Now that's kind of the BIM user. From 100 become 80. But now if we're talking about the computational BIM user, or the one that knows or the one that use, right? So it's going to be much lesser than that as well, right? So maybe from 80 BIM so-called user become, say, maybe 40. Okay, so, right? Now, out of these 40, right? Out of these 40 computational BIM user, for example, these are the one that, first of all, some of they know how to create. They know how to create Dynamo scripts, then things like that. But some of them only know how to use it, as in the, I mean, mainly they just use it. They don't know how to create a script, right? But they use computational BIM, just using it. Like, say, for example, automation, some of the creating some sheets, running some script here and there, and all these things. Okay, so that's become so. When you talk about the creator of the scripts getting lesser again, maybe less than 5, that kind of thing. So I think when we hear about NBBJ, that he said that, and Has saying about, okay, they have like a group of 10 people there in the office. I mean, that's a quite good number, I guess, right? I mean, there's a lot of people that knows about scripting and programming and web and C# and .NET and so on and so forth, right? Now, looking into this, right, does your course is actually focusing on which user here? Because at the end of the day, at the end of the program, for example, as a mechanical engineer's degree students that graduated from your course in SIT, what is the target that you're trying to achieve here? I mean, because technically right now in the industry, these are kind of the situations, right? I mean, especially for the creator, like the one that really knows how to programs, C#, Python, and so on and so forth. That's maybe like less than a handful of people. I mean, so to speak.
Okay, to answer your question, actually at SIT, like I've said, we are training mechanical engineer for the built environment. We provide all the students in a cohort. We usually have about 60 students, at least about 60. So these students, all of them knows how to use Revit very well because they've used the Revit to do real life projects. So the students know how to use Revit. Obviously, the skills will be different from student to student, but at least all of them are very familiar with it. Then we also expose all these 60 students to how to use Dynamo. You know what I'm saying? So our mission is we want to be pushing new form of new form of graduates to the industry. Graduates that can actually use Revit and also at the same time have basics on the computational BIM, at least Dynamo, for example. So that is our mission. So now, whether the students will now move in that line will now be a form of interest, for example. In fact, some of our graduates now, although we train them to be mechanical engineer, they are now computational specialists in their company. They are computational specialists. So, and some of them are working for contractors. So what we are doing at SIT is to push this, in fact, majority of them are Singaporeans, over 99%. We push all these students outside to the industry, which currently now we don't really have a lot of that, like you said, and I agree with you. We are pushing a lot of this because this is very new. We started our program in 2015. So we are pushing new graduates out now after 4 years. So we believe in future, we will have a lot of these students with these skills. Whether they will now move in that line will be a function of interest. But from university point of view, we are providing them the Revit skills. We are providing them the basic computational BIM skills, which is, for example, Dynamo and Python. And not just training them. SIT is a University of Applied Learning. We contextualize the training, so we give them real life problem. So so we hope that if they are interested in future, they have a starting point. So hopefully in future, this kind of problem we are having will be lesser, because there's a university pushing a lot of building service engineer into the industry, not only to be a mechanical engineer, but with the skills on Revit and at the same time on computational BIM. When we first started in 2015, there were very little people in the industry even with Revit skills, even till now. So that is why a lot of companies, they appreciate our students a lot, because they are unique. They have these basic skills, which the experts in the industry can tap on and train them. For example, if somebody comes to your company like that, you are the expert. You guys can easily take them to the next level because they already have a very good starting point. It will be easier to train them because they have the necessary skills and knowledge.
Yeah, I mean, I think it does make sense for Revit or any BIM software that architects or engineers to be familiar with, because that is the replacement of pen and paper indirectly, right? But now learning computer coding, like programming, that's a totally different thing, because that's perhaps is quite far from their domain knowledge as an architect, from their domain knowledge as engineers, from their domain knowledge as a structure engineers. Because I think that's a challenge right now, how to have a person that have two sets of skills, which is one is as a computer coding, and at the same time also he's a domain knowledge expert as an architect or designers or engineers and so on. Right? I think this might take some time, in my view. Yeah.
I will also expect the student to learn how to collaborate, because you can't do everything, for example.
Correct, so, correct. Yes.
For example, in a research project I'm doing now, my students collaborate with students from ICT. Because the student from ICT is well grounded in Python, a lot of coding stuff, and my students have the domain knowledge in built environment. So now, at the moment now, they are collaborating to work together. That's another kind of training we are providing to them through research projects. Through research projects, we put students from different programs to work on a particular project. So hopefully, in that project also, some of them that are opportune enough to be in the project will learn how to collaborate very well, and will also learn some new stuff about programming from students from other programs. So moving forward, I would think students will need to learn how to collaborate, because obviously you can't do everything. And programs are designed most of the time for a particular purpose, and we can't dilute that also. So how to bridge that gap is by ensuring that as part of our training, we are training students to learn how to collaborate with people from different disciplines, because that is reality. But you need to have fundamental knowledge. Higher level, you let the expert do it, but fundamental knowledge, you need to have it. So that's what you are doing.
Okay. Maybe I'll ask the questions to Mark. Mark.
Yeah.
Yeah. So in your opinion as well, right? I mean, you find this kind of two groups of your kind of trainees that they know more about the programming, and the other one is very difficult to adopt this kind of programming kind of or coding kind of knowledge in a way.
All the time.
All the time.
Daniel, all the time.
I saw one question asking, there are some people good in scripting, some people good in design, but if you find combination of both, then you'll get the right
then
manpower.
Jobs,
But you gotta pay them very high. So yeah, what's your opinion?
I think everyone it's I mean we've seen a lot of students that come across learning certain, like, okay, I mean, we focus on Rhino and Grasshopper, and then so the challenge is, I mean, if it's 6 in a class, you probably got 2 really quite outstanding one, you know, that they will have to figure things out, but then you lost the 4.
Yeah.
You know, so I guess the probability is probably about 20% in any class, I think. You know, if you could get 1, it's remarkable, because I think everyone wants to have a hand in it. But I did often tell them, I said, look, even I am still trying to understand some of the things. You know, I probably don't understand everything, but I think I can get enough to get things going. That's it. I say the basis is, if you lost interest, then end of the day, you just sit there and then, I don't know. I mean, you probably have to fall back on CADing. If you cannot do programming, cannot do scripting, you jolly well better be good at modeling something, you know. I mean, you have to have one or either the other. So I did share with them, I say, learning these programs are cool stuff. You really look cool. But end of the day, I say it has to translate to something that it pays your bill, and at the same time you get some work done, you know, and that's the reality. You know, that's why I asked Harsh how many people really focus on development in such a big company, you know, and you realize that it's also not many. And I mean, in Singapore, it would be even rare to find any programmer that understand all this mix. I guess the students are fortunate now to be exposed to different arena, but then they don't know where to apply. That's something that probably it takes some time. I believe it will come through, but it will probably still take some years to happen. So small step helps, you know. So, but I guess they probably would have fun first, you know, not too serious about certain things. How many computational people in ONG&ONG?
We don't have that many. I mean, we have we have less than 5, definitely.
Yeah, definitely. Yeah. See, so,
yeah. I mean, even that one is actually across the entire offices, because we have a team in Vietnam and Singapore, Malaysia, and all that. So yeah, I mean, Vietnam, we have a couple guys, you know, all these. So yeah, so it's difficult to find this. I mean, we can find programmers, for example, but these programmers, they may not understand building or AC industry kind of workflow, or understand the whole building put together. So yeah, that's always the challenge, right? To strike a balance between someone that knows building industry, which is AC industry, as well as the one that know how to program or know how to do coding, right? So it might take some time, as Professor Moshood says. I mean, you know, hopefully there are more institution or educational university and all this to forcing all these things to happen. Yeah. But yeah, it takes some time.
Yeah, let's have fun first before it gets too serious.
Okay, let me just go through this, because there's so many questions from the live this Q&A thing. So okay, let's just. Quick question for me. Okay, will the simulation like CFD, fire simulation, etc., be under architects based on computational BIM? Well, right now, when we do projects, normally this one is under architects, and if that CFD calculations or all the other simulation is actually quite a big scope, or maybe like such a large development or site. We also normally so-called outsource it to the like a CFD kind of a specialist, right? Because in for example, in government kind of tender projects, normally we also need to put in the CFD specialist, the CFD consultant, right? So that particular or sustainability consultant, sorry. Yeah, so that could be under separate entities. But again, I guess it depends on the size of the project. Whether the project is large enough to have that exercise be done separately as a, from different entity or from different kind of company, rather than, you know, under the architects. But normally, of course, as an architect, we need to understand the basic principle, all these kind of simulation due to the fact that it will affect it, the way we design the massing. For example, when you design massing block and all these airflows and everything is related to that. Yeah. As a conceptually, as a feasibility study, perhaps architects need to involve at that stage. But moving forward as an ongoing thing, because all these processes of sustainability design as a feedback is not just at the early stage. I mean, BERII has to go throughout. Like we keep testing, and until make sure that there's no issues with all of these things. Okay, so I think if I can answer, that is my answer. Right. So the other question is to Professor Moshood and me. Okay. Currently in the industry, architects and engineers actually still pass the CAD file to BIM specialists, and most of the time, the BIM specialists are not able to calculate and make decision. What's your opinion on the currently work process? Is it in your company now practice full BIM implementation, start from design stage? Okay, in ONG&ONG context, yes, we are practicing BIM from early stage of the design all the way until the project is finished, as in handover, the as-built. Okay, in regards to that questions about BIM specialists, okay, all right, I see what you mean. Okay, so basically the architect just done AutoCAD and then passing it to the BIM modelers or BIM specialists to do the model. Okay, what we are encouraging to all of our staff members in our practice is basically the designers or the architects or the engineers need to do BIM as well, right? Because some of the, yes, you're right, some of the decision needs to be done by the architects. And then also architects is the one that understand the building code, the checking of the regulations and so on and so forth. And so architects need to understand BIM. So our approach is the same. I mean, we want the all our engineers and architects to do BIM right from day one. Okay. In fact, actually, we're trying to so-called eliminate all this 2D process from the beginning. We start drawing floor plan from Revit from the beginning. Okay. Professor, do you want to add something to it about these questions? Yeah.
If I may comment on that, please.
Yes.
I think what we are experiencing currently in the industry now is a function of the kind of training that we had before. Before, people were trained specifically either in architecture or in engineering aspects. They were not trained in the Revit software and so on and so forth. And that is why we are having this kind of problems. Mm-hmm. But moving forward, I think universities should be training students also on how to use all this software to either carry out their architecture training or their engineering training. If I may tell you, there is no design studio in the whole of Singapore with regards to BIM for mechanical engineers. There is none. Mm-hmm. So when we started this at SIT, it was the very first one. So what I'm saying in essence is that these students are being trained on how to design mechanical systems and plumbing systems. And at the same time, after the design, they also know how to now use Revit to bring it out. They now know how to also now use computational BIM to see how they can streamline the process. So this is the kind of training that engineers should be having now. Of course, the first thing is to be an engineer, but they need to know the tools that can help them improve their productivity. And that is where all this BIM coordination, BIM software, BIM, computational BIM will be very useful. But previously, we didn't have this kind of training. So that's why we hope that at SIT, for those students that are interested, if they go on into that line, they can also use their engineering knowledge while at the same time they use their computational BIM or BIM skills on those kind of stuff. Yeah.
Okay. Yeah, that's right. I mean, that's the goal. I mean, like we want everyone to jump straight into the BIM software without, doing it in other platform first and then get someone else to do it for them, right? I mean, that's kind of, I guess, the for the interim kind of solution for now, because I understand that some users or some architects they don't even kind of into this BIM yet, let alone computational BIM, right? Okay. Yeah. Okay, so just looking at the time here, all right. So I think perhaps I'll need to jump quite quickly. Okay. Right. So I saw a lot of questions to Mark about the software. Rhino, I think Mark, you already answered this in the Q&A chat.
Yeah, I don't like to leave it hanging.
Yeah, that's okay. That's good. That's good. Okay. I think you answered all of them, right?
Yeah, no. The thing is, I think the practice is it's gonna phase out. I agree with the professor, and then it's gonna eventually phase out, and then hopefully one fine day one, even ONG&ONG is still trying to phase out all the old way of working.
Yeah.
So it's not gonna be overnight. I think we all agree with that, and
of course, yeah.
Let's see what happens in times to come, and I think it will change. It will definitely change.
Yeah. If I may answer this question, somebody asked this question: are there any research done in the aspect of 5D BIM on cost from computational BIM? So I have 2 papers here. Hopefully I can share with the organizer. You can see some of the work done on 5D. So basically using computational BIM for quantity takeoff. Using computational BIM for quantity takeoff. So hopefully, if the person is interested, I will share with the organizer, and they can share with everybody, something like that. And somebody also asked, in future will BIM engineer, we will have BIM engineer instead of BIM coordinator in the industry? I would say that our mission at SIT is to produce engineers that knows how to use BIM software to solve problems or to improve the process of solving problems. So I don't want to call them BIM engineers. I want to call them engineers that knows how to use computational BIM or all this BIM software to solve problems or to improve the process of solving problems. BIM coordinators, already we have that, but currently in Singapore, very little people knows how to use BIM software to improve the process of solving problems. Hopefully at SIT, we can train people with capability. But whether the student will now have interest in such an area upon graduation, that will be a function of several factors. Yeah. But our mission is to create engineers that knows how to use computational skills and computational knowledge to improve the process of solving problems. I hope that answers the 2 questions.
Yeah. I think perhaps if I may say, maybe the question is relate more on whether engineers and BIM modelers, because BIM coordinators, when everyone knows how to use BIM, for example, we still need perhaps someone that coordinate the whole entire process across multidisciplinary in all that, so-called the BIM manager or BIM coordinator, in a sense, right? But because BIM managers and coordinators, they are not modelers. I mean, they're the one that's actually coordinating the whole entire kind of a project workflows and so on and so forth. With VDC and IDD, the one that BCA is actually so-called promoting now, these processes actually need someone like you to manage the thing. Either the guy called BIM manager or BIM coordinator, that's probably a different topic, but it's so-called the one that can manage the whole thing, right? The whole entire thing, but not the modelers, of course. Yes, I agree with Professor Moshood that there won't be any modelers anymore. We shouldn't call them modelers. We just call them engineers that knows how to use BIM automatically, or we call them architects that knows how to use BIM automatic. I mean, by right, So yeah, that should be the way. Yeah.
Another point I want to raise is this BIM coordinator that we have in the industry now. It might be as a result of our process of doing our work. Maybe in future, if you streamline our process very well, if everybody is working together integratively, if there's a common resource for integration, we might not actually need BIM coordinator in future.
Yeah.
Talking about productivity now,
yes.
Talking about lean thinking. So the need for BIM coordinator now is mainly because, from my own perspective, everybody is working separately. There's no integration. So you need somebody to physically pull all of them together. What if in future we streamline our process in which everybody works in an integrated manner, the need for BIM coordinator will be lesser because technology can easily coordinate everything.
Yes,
I mean,
yes.
just something to think about for everybody.
Yeah, I mean, I guess that's the whole idea of CDE, common data environment, and all these things, right? Which can streamline the whole process. I guess that platform, like you know, all these CDE platform actually aim for that as well, right? To ensure that we don't need someone to monitor everything. We just look at the dashboard on the screen. Okay, the dashboard say, okay, this needs to be highlighted. Then that's the so-called that's the single source of truth panel that you can always look all the time, and that's the one that actually directing you what's the one that actually missing, what's items actually still outstanding, and so on and so forth. So therefore you don't need coordinator. I mean, yes, that's right, but I think right now perhaps the adoption of that also still lacking, right? In addition to what the current problem of the BIM users and computational users and so on and so forth. Yeah. Perhaps maybe from, is Casey here still? No, he's not online. Okay. Casey, you're here? Okay.
Yeah, I'm here.
Okay. Yeah, hi. Yeah. So from Autodesk, for example, what's your view on this? I mean, in terms of computational BIMs and how these things going to move forward from the software vendor point of view. I mean, we can see that the computational BIM right now, I mean, perhaps it's not user friendly, or it's not, I mean, not user friendly for the one that knows, but the one that doesn't know, when to or to attract these people, or to attract the layman, for example, right? How to make them use more, and how to make them perhaps in Autodesk terminology is Dynamo, for example, all these things. What's your view on this?
To be frank, as of now, if you look at the industry, right, computational design is one of the challenge because not all the users are able to pick up the skill set. So if you look at the market, maybe less than 50% out of it that knows about the computational BIM. But if you look at the whole industry, the educational line is starting to have those kind of syllabus or teaching about computational. BIM is one of the essential, just like we moved from CAD to BIM many years ago. So I believe this is just a transition, and moving forward, computational is part of our essential day-to-day works.
So does that mean you guys going to develop something that is more easy to use, like without user no need to know so much about Python and C# and .NET?
Yeah, that is one of the direction as well. But we know that sometimes we cannot get away from all those kind of
okay.
Because the industry requirements is getting more and more advanced. In fact, whatever the standards that we can provide, right, is not be able to meet the requirements. So we still need those kind of programming to have the flexibility for the users. But you can see over the past 2 years, right, computational BIM, especially on Dynamo, Grasshopper, they start to have more user-friendly interface, easier for users to learn from. So.
Yeah. And do you think something like a dashboard that can capture everything and then highlight everyone or highlight all the stakeholders, you know, about what's going on, so we don't need so many managers, we don't need someone that need to monitor the projects anymore, or so-called BIM manager? Is that possible to happen from vendors?
You see, many years ago, when we start to talk about IoT and robotics, right? People start to question whether do we still need those kind of workforce in the industry. So same thing as well. I believe, to my personal opinion, right, computational is still the same, almost the same argument. To me, we still need those kind of expertise. We still need a project manager to monitor the project. the tools will only help them to help their jobs easier and to help them to have a more visibilities to it. If I look at the industry right now, a lot of industry, right, start to use a platform such as like Power BI to help their day-to-day job.
Yes.
If you're asking me whether do we still need those kind of workforce in the industry, I believe we still need that, because that is something that the computer cannot learn from, because it's based on the experience and also based on their expertise.
Okay. Yeah, because we know that I mean, at least for Singapore, everyone sort of need to embrace the whole digital future, digital kind of workflows and so on, right? So that's something that we need to I guess embrace, lah, right?
Yep, definitely.
Okay, so just looking at the time, how much time we have, Yvonne?
You have 12 minutes. Yeah.
Oh, still good. All right.
Yeah. 12, 10 perhaps.
Okay, maybe we do just go around the table. I mean, I don't know whether Pong, are you online? Can you give some thought about anything about our discussion?
Okay. Hello.
Hello. Yes. I was online, but I have several tasks on hand. So
okay. Can you chip in a little bit?
I understand that there's actually a Python Dynamo course in the coming November. Okay. From SIT. I think this is a good platform to share this piece of information for anyone who want to, learn programming. Yeah.
All right. So, okay. Anything else, Pong?
Okay. Like I shared earlier on, thank you, Pong. So we have 2 courses, one on Dynamo, then second one on Python. So if anyone is interested, Pong has all the details also. So another point I want to add is this: while we are learning about computational BIM and all those kind of stuff, I think the industry is not embracing lean thinking, L-E-A-N, lean thinking. If we really want to improve productivity, because the whole idea of this computational BIM is to improve our productivity, to make it easier for us to solve problems easily, we need to adopt lean thinking also. If we can adopt lean thinking, it will be easier for us to know how we want to streamline our process, so that whenever we now bring computational thinking into the whole topic, the benefit of computational thinking will be enhanced. But right now, the industry is not really talking a lot about lean thinking. We talk a lot about technology. I think if we can use technology, digitalization and lean thinking together, wow, the benefit inherent in digitalization will be enhanced. People can see it easily. So, but right now, we don't talk too much on how we can streamline our process, how we can remove waste from our process. I think it's right time for the industry to be talking about that. How can we combine digitalization with lean thinking? I think that should be a way forward to improve or to make the benefit inherent in digitalization to be more obvious. We need to combine both together, lean thinking and digitalization. So I think something.
If I may add, yeah. So sorry, Prof. If I may add to that, right? I think perhaps I would like to add. It should be, I would say, is a front-loaded effort and lean thinking at the same time. Because when I say front-loaded, it's just like BIM process, right? You don't get your drawings for the first few weeks or for the first, few days when you do the modeling. You can't get the floor plans and section elevation right? Because you need to model it first. So a lot of front-loaded effort has to be done. I mean, this is the kind of process perhaps the industry need to understand, that this is a new workflow. It's a totally different workflow from CAD, because from CAD you just draw quickly floor plan and then just issue it straight away. But in BIM cannot be that. I mean, you have to put a lot of effort from the front, at the early stage, to get the benefit towards the end. You see, yes, it's overall productivity as a project, but it may not be. But it may be not overall. But it may be like it's not a great productivity every single stage, right? Because at the front stage or the early stage of the project, you may see lesser productivity though, but especially when you're still freaking around with all these C# programming and Python script that it doesn't work, and then only for the last 1-2 days before the deadline everything works, then bang, everything's done, right? Because you've done it through the script. But the first 10 days you don't see anything because you can't see this this result immediate. That's what I'm trying to say here. Yes, digitalization helps on the productivity, but again, just like when you see the famous curve from I think that beam curve, forgot McLean curve, right? So that one is always talking about the front end effort. You put the effort from the beginning first. When we're dealing with modeling, when we're dealing with all these tools, yeah, because that's what we're always facing now. And the people, especially for projects team that doesn't understand this, they are very they're not patient with all these processes. They want, oh, I want the drawing now, I want this now, I want this now. But in fact, it's okay. Please wait a little bit because we need to resolve this thing first. Once this thing resolved and that's it, everything is plan, section, elevation, detail, everything's all done automatically, right? So that's the whole idea. Yeah.
I totally agree with you on that. But my only concern now is that if after taking time to design using technology and everything like that, downline in the process, we still encounter the same problem. People still follow the normal practice. We spend a lot of time using digitalization or process and everything like that, so that the later stage will be faster. But when you get to later stage, people don't actually use the outcome of your digitalization efforts. Yeah. So like now becomes like waste of time, waste of effort. I think if we can take time to do our digitalization properly, of course it will take time. I totally agree with that. But if we now make use of it downstream without going through our unproductive way again, then I think we can see the benefit inherent in the digital technologies. Yeah. My only concern is that we don't streamline the process. Even after we spend a lot of time at the design stage, when you come to construction stage or FM stage, it's like back to square one. Nobody sees the benefit that you put at the beginning, because you put all these benefits at the beginning so that later stage you won't have problem, things will become faster. But you know the practice, even at later stage, it's still back to square one because people will not make use of your effort at the earlier stage. Yeah. I think we need to think about how to streamline the process, how to integrate digitalization across board, design, construction, and FM.
Okay, understood. Yeah. Thanks, Professor. Okay, maybe we do anything from other speakers, Mark? Any more comments, Casey?
I want to say that after hearing all this chat, I think finally is really managing the expectation. It takes time. It's you know how everyone thinks that by putting some components together, magically things just happen.
Yeah.
So exactly, yeah. And then even some of our customers say, you know, why is it taking longer than expected? I say, why don't then back to your drawing, you know, literally. But then I have to say, I just want to add to the note is, I did tell some of the students, I say, if things are way too complicated for anyone to start with, I think you just fall back on your modeling. You know, really, you just have to fall back on your modeling, and then make sure you have something to deliver to your end customers, and just you need to kind of take them through the effort of saying that, you know, computational really takes time. I agree with Professor. I agree with you, everyone, that you really need a change of timeline for even the customers too. I think the client do not expect that it is so difficult. And the bosses will think that it's just a couple of components and then you're done, export done. So it's not that straightforward, I guess. So maybe we need to teach the bosses managing computational expectation.
Yeah. Okay. Anything else, guys? Casey, anything more from Autodesk?
No.
No. No. Okay. BCA, PONG. Any more?
Yeah, I
comment?
think that's it. So for this session is very fruitful. Let's look forward to the next one, and hope that there is some industry, tripartite approach that works together with Prof. Moshood over here from SIT. Some research project.
Yeah, thank you very much. So if
Just
anybody
one
would
more
like
thing, guys. Yeah, just before you guys go, just one more thing. ONG&ONG, as you know, this is my last. This is just an announcement. Okay, just to add. Last year we have this Beyond X, right? 2019, but just today, because due to the COVID, right? We will not have this thing in so-called in our office anymore. So we do it online. So if anyone interested to see this, the event is next month. So I would like to take this opportunity to announce it to the audience here. And yeah, if you would like to see, then you can register using this one. So, sorry to interrupt your thing, Professor. Yeah, you may continue. What did you want to say?
Oh, thank you very much. So if anybody would like to contact me for possible applied research, I'll be more than happy, because like I shared just now, we are using Dynamo Python, at least for now, to streamline process for at the design stage, construction stage, and FM stage. If anybody is interested, make use of university, because in university we have engineering department, we have IT department in which we can collaborate. So at the back of my slide, I already have my contact there. You can also Google my name, you'll find my LinkedIn. Just send me email. I'll be more than happy to reply, and so that we can collaborate and seek funding. Funding could be from SIT or from outside also.
Okay. Yep. Thank you.
Thank you.
You're welcome.
All right. So if there's nothing else, then perhaps we can end today's session. Thank you very much for all the speakers, Professor Moshood, Mark, Casey, right, and then also thanks to Harsh. I know he's still sleeping now because it's very early in the morning still. Anyway, okay. Yeah. Yep. So anyone who is interested to want to see Beyond X event online can join us next month. That's the registration link over there. Okay. Yep. If nothing else, then that should be it. Okay, we can end the
Okay.
Thank
the
you.
work group today. Yeah. Thank you very much for all the one that attending already.
Thank you.